All right. Thanks everyone for showing up and being a part of this DIT-WIT Networking 101 webinar. I want to say thank you very much for coming and being here. We have several speakers going to be giving their expertise about what to go over the basics of networking for your cart. This is going to be recorded on YouTube, so you can reference this later on. There should also be a white paper and zip file down below in the description of the YouTube video, so you can take a look at that if you need to. The runtime for this is going to be about 4 hours, so strap in. It's going to be great. Let's see, each chapter is going to be about 10 minutes or so. There's going to be a Q&A session at the end of each chapter, so please just save your questions for that moment, and if you have anything, we'll get to it. Q&A will also run about 10 to 15 minutes. And if you can, just use the raise hand feature, and I'll get to your questions in a timely fashion. If you don't want to raise your hand to speak, there's going to be you can use the Q&A section of the chat to ask your question. And for anybody who's interested in getting those things done, those questions answered and whatnot, please upvote that for emphasis. Up first is going to be Ryan Wynn, going over any sort of key components to get your cart up and running. So Ryan, go ahead.
Hey everyone, thanks for joining us today for our DIT Networking 101 module. Now guys, I want to stress the kind of material that we'll be covering today. We are addressing a very wide audience here. So a lot of you who have worked with Ethernet networking before, a lot of this is going to sound familiar to you, if not a great refresher. We created this module in response to some confusion about, what problems Ethernet networking happens on set. So for the absolute initiated, this means being able to interface with a bunch of different motion picture equipment and devices, right? An Ethernet network is going to be able to bind all of your devices together in physical, logical, and virtual ways so you can talk to it. What this does is it allows camera control. It's going to allow, this is the basis of live grading. This is how we communicate with our LUT-boxes, right? So by the end of this presentation, you're going to be able to feel confident, at least to begin creating and managing your own online network. On-set network, I'm sorry. I do want to say that all expressions of wireless and radio frequency management is going to be in other modules. We are just talking about hardline Ethernet protocols here. So there's a lot to cover, so bear with me as we move through all of this. And once again, we are addressing a wide audience. Here's what we have on the schedule today. Our curriculum, it's going to be broken up into several sections. To begin, I'm going to be covering some of the devices and software for you to get started, right? We're going to meet the cost. Section 2, we're going to be putting them together. Then we're going to verify the network, stress test it, equip you with some essential terminal commands, and then finally some additional resources at the bottom for further reading and reference. This is a great time to talk about the zip file that was just posted on the DIT-WIT page as the event page. Given the opportunity, please download it. It's about 250 megs, give or take. Inside, you'll find user manuals and a copy of these slides, actually, so you can follow along. And more importantly, our white paper. DIT-WIT has been working hard over the past several weeks authoring a white paper for Module 101. It is an evolving document. So it's a bit of a rabbit hole, but we've gotten to the point where we're really comfortable about presenting what we have so far. All right, let's move on to the next slide here. This is a flowchart, a Draw.io diagram, courtesy of Chris Bolton, who's behind a lot of the visuals for this presentation, by the way. What we're looking here is a simple flowchart that illustrates a typical on-set network. Now, I know there's a lot of information and junk on the screen, but what I need you to glean from this is that there's going to be your computer, your router, your switch, 2 cameras, 2 LUT boxes, a video router, and its control panel. The slide is going to come back several times throughout the presentation, so don't worry if you get lost with all of this, but we're going to be using this map as a way to kind of like talk about what's happening inside of your network. All right. Let's start with software. So not really much to talk about here. Generally speaking, if a device has enough development and use case behind it, chances are it'll have its own web page managed portal. If you've logged into a Teradek Color, you know what I'm talking about. If not, if you've logged into your printer, some printers have web pages that you can log into, same sort of thing. When there isn't a web page to use, there are utilities or apps usually. For example, is the IP utility, remote utility for Box.io from Flanders. They're constantly putting updates out for this utility, and in a way, it's a great tool to have in your back pocket. In fact, the most recent update was maybe about a week ago, and addressed some really useful things, such as being able to pipe a picture through the Lightbox without LiveGrade open. But I digress. So where there are no utilities or web pages or GUIs to use to manage your device, it's either completely unmanaged or you'll probably be talking to it through command lines. And once again, that's something I'm going to be covering on later in the presentation. And it's worth mentioning here that sometimes drivers are needed, right? It's worth mentioning that some specific devices may require that for your computer to interface with that. So if you're stuck, part of the troubleshooting process means double checking that you have all of the drivers from the manufacturer website. Yeah, we'll go over more about troubleshooting later on. We have a section completely dedicated to that. LandScan is one of several myriad of products that deserves an honorable mention. It's very simple to use. And as the name of the software suggests, what it does is it scans your network and you kind of get to see who's connected, right? It's kind of like your own virtual roll call. And so that's part of the software. And we're going to start talking about the hardware now. And before we talk about the specific unit that we'll be using to demonstrate throughout the presentation, I want to talk about what a router is. So most of you are familiar with the basic concept of a router in terms of like it's something that connects you to the internet. But in the context of an on-set network, the router is really the heart of your cart, your network. It's going to bring everything together and unify all of the devices. Sometimes it's referred to as a gateway, and you can think of a router, it's in the name, it's quite suggestive. It's like a traffic controller of sorts. It's what, manages the traffic inside of your network with rules and regulations that you yourself can manage, being the own administrator of your network. Here's a little piece of trivia. Back in, the dial-up days, a router wasn't needed to connect your computer to the internet because you would only ever have one computer connected to the internet per household at a time. So unlike today, when you walk into a household, there's dozens and dozens of different devices that need to be connected at once. And essentially that's what, this is the technology that we're bringing into an on-set environment for our use case. Specifically, here is the Edge Router X from a company named Ubiquiti. There's a bunch of different options out there. We decided to use this as a platform to demonstrate some of the objectives and concepts that we're going to be covering. You're of course feel free to use whatever hardware that you like. So once again, this comes from Ubiquiti. They put out a lot of enterprise grade hardware at very reasonable prices, which makes it really attractive for us. So you can bring a lot of features, into your world for a very relatively low entry of cost. Just like many other different routers, it does have the ability to export and import configuration, so you can reflash it in an instance. And in fact, in the zip file, we've provided a configuration file for you to get started with everything set up for you to begin. So physically speaking, this device has 5 ports, right? You can see them right there in the picture. Now, these ports are called RJ45. You've seen these before. They're on the back of, a lot of devices. They're on the back of PlayStations, Xboxes, and printers and such. Now, one thing to note about this router in particular is the furthest left port is a configurable port. So this is what you would use to kind of interface with the Edge router for the first time, as well as you can configure it to accept an outside internet signal, quote unquote. So you can push all of your devices into a wider area network. More on that later. So really you have 4 other ports to use. Now let's talk about power. It does. It's very easy to adapt into a 12-volt system because that's exactly the input that it takes. So you can adapt it however which way you want. DTAP, LEMO, 4-pin XLR. The point is it runs off 12-volt. If you can get it in, it'll work. That's the beauty of it. And I do want to talk a little bit about what's on screen here. You might notice that there's mention of PoE, pass-through. We're not going to dive into that too much. I just need you to understand that stands for power over Ethernet, okay? Really what that is just a standard that allows current to flow through, an Ethernet cable. So, if you can power this with the furthest left-hand port, that's great because that's, one less wall wart, less cables, less heat, we all win. So some of you might be thinking like, okay, great. So I've got, an Edge Router X on my cart now, Velcro to my deck. But you said there's only 4 ports to use. How do I get more hardwired devices in? Well, this is where we enter the network switch. So the switch is, reading the definition of the switch, I know it sounds an awful lot like a router and that it kind of distributes traffic and such, but the key pragmatic use case of a switch is that it allows for additional ports to use, right? You can very much think of this like a video DA, a distribution amplifier, or you can think of this as like a standard power strip. You've got one off the wall and you need 6 more in your living room, just like that. That's what a switch does. There's some internal procedures which makes this possible. We're not going to go into that, but that's what allows the switch to behave the way it does. Is there's an intended source and there's an intended destination. They do come in managed and unmanaged flavors, and we'll touch on that on the next slide. In the case of some switches, there is no GUI at all, no utility and no nothing. It's just a piece of hardware that distributes the signal. So really, once again, I want to really drive home the point that a router is what's going to manage your network, and an unmanaged switch is just going to provide you additional RJ45 ports. Yeah, so with a managed switch, for example, there are heaps of advanced features that come along with that. So it's basically a switch with extra features on it. We might not ever need to use that in a non-set environment, things like VLANs and such, but it is nice to have ready to go given a future where that is required. Let's look at a specific example of a switch. This is the black box LGB304A. I know you can read that too. This is small, cheap, and robust as a network switch. It fits in your pocket. It's an all metal case around it. And in fact, because they're so inexpensive, I recommend that you have a couple of these in your kit, right? So that way you can kind of stick it anywhere that you want. Just leave them on the truck the same way you would with some extra power cubes. Here's the key thing that we like about this switch to start. It works off 5-volt power, which means you can run this off a USB port. It consumes a nominal 2 to 3 watts, so it has an extremely low power draw. If you don't have a USB outlet available, it'll take 12 volts as well. It'll set that voltage range. But as far as 5 volts go, it's great because you won't need an additional outlet or anything like that. And it's just a DC barrel at the end. Very cool. No PoE for this, I should mention. But let's go on to the next slide here. Is another example of a network switch. This is the, excuse me. Trying to advance the slide here. Stand by, guys. There we go. Thanks. Sorry about that little technical snafu. So here's another example of a switch, right? This is the Netgear GS108. I actually have one with me, just so you can kind of get a feeling for its size against an average human hand. The difference between the black box and this is not only is this a little bit uglier, but instead of 5 ports, you now have 8 to use. It requires 12 volts instead of 5. So plan accordingly as to where you want to stick this. A bit of Velcro works. So not only are these very inexpensive and unmanaged, just like the black box, but these are readily available. It comes from Netgear, a very long-standing trusted company. These are probably available at your local electronics store and Amazon. So if you're in a bind and you find yourself needing additional ports, that's what I would look at. Let's see, advancing to the next slide. Thank you. Okay. Now that we've gone over the router and the switch, let's talk about the cables in which this will all physically be bound together, right? At some point today, I believe we're also going to cover how to crimp your own cable. As you can see in the picture, when I say RJ45, we're referring to the physical connector head, right? And the Ethernet cable is what is flowing with the actual cable, right? It's the same thing to SDI to BNC to USB versus USB Type C, right? So there's protocol and then there's a physical connector. So remember, RJ45 is the physical connector. In a couple of slides, we're going to talk about what Cat6A means. So these cables come from Monoprice, and what they do is they offer very affordable, high quality cables that you can work with right off the shelf. But yeah, if you want to crimp your own, all of the benefits that come along with it are available to you. You get to choose your own color, your own lengths, and just really make it your own. These specifically are super thin. These are rated at 23 American wire gauge and make for great internal cart runs. Anything, maybe less than 6 feet. I would liken them to, the Belden 1855A in that regard. You really don't want to be doing long runs with these, with this. The Cat6A can carry a power over Ethernet signal, so it does carry current, but like I said, because it's thin and you really don't want to be pushing that over long distances. Moving on to the next slide. These are exactly the same as the ones that are before in that they are Cat6A. The difference between this one and the other one is this is much thicker and more suitable to carry PoE at longer and greater distances, right? Not only that, this is a little bit more sturdy. So if this Ethernet cable is going to be leaving your cart in any way, this is the cable in which we recommend for you to use. All right, so let's talk about CAT. Like all of this mention about CAT, what does it actually mean? So CAT is short speak for category. Really, this is their way of keeping up with the revisions and generations of improved bandwidths and capabilities over time. As you can see at the very bottom, we have Cat6A. That is the most currently the most consumer available, future-proof and long-withstanding cable to use. Yes, there are CAT categories preceding Cat5, but they've all been deprecated. In fact, Cat5 is just there for reference. We really only recommend you start no lower than Cat5e, which is when you enter gigabit space. As you can see on the max data rate column there, it is available. It is the first generation that can do gigabit Ethernet. So running Cat6 and Cat6A is going to be a little bit more expensive than Cat5e, but you're going to be future-proof. So if you have the capital and you can exchange, that exchange of expense is going to let you feel more comfortable about reusing your cables for future configurations. And another thing I should mention is yes, the max distance, technically speaking, is 100 meters, but always take that with a grain of salt. Same way that, engineers advertise the theoretical maximum for bandwidths. Really, it's up to you to make the decision of what cable is going to be right for the situation, for your use case scenario, which include how flexible it is as a cable, its fidelity, and what kind of feature sets that you require. Okay, moving on to the next slide. What? There we go. Thanks for keeping up with us, everyone. So if you're a tinkerer, we were talking about crimping cables just a moment ago. Something looks like this. Once again, you can find these at your local hardware store. Terminating and crimping your own Ethernet cables is a very common practice outside of the film industry. And any good one will come default with some blades for cutting, and then a place where you can terminate your heads. So right now on screen is an example combination of that. We're suggesting the easy RJ45 connector. It's really just about cleaning up the cables and lining the pins up and just physically crimping them. Once again, we're going to have a full demonstration about that later today. And right now is a good opportunity to return to this flowchart, which brings us to the end of section 1. This is where we open up the floor for the Q&A. But let's revisit this flowchart now that you have an understanding of what's going on, right? On the far right-hand side, you have the laptop, which is your computer, right? And then right in the center of the screen is your switch, and that's connected to your router at the top. So the router is where everything is managed, and the switch at the bottom is what will give you additional ports. And that's where you can plug in, your actual control panel and your video router and such. Yeah, 2 cameras as well, and 2 separate LUT boxes. Later on in this presentation, and I failed to mention this earlier, is that we're actually going to be showing you how to connect the LUT boxes. We're going to be covering the Teradek color, and we're going to be looking at the Kumo switch and such. And really, these are the procedures that once you're able to do it with these devices, you're going to be able to do it with anything else, because the protocol is pretty much the same with everything else. But I hope that was a really comprehensive introduction, a ground zero review of what the Module 101 is all about.
All right, it looks like we had one question. I think Ryan Pollock had a question, even though he took his hand down. So Ryan, if you want to ask your question, feel free. Go ahead. You are able to speak.
Yes, hi. So if you're replacing your older Cat5 cables, and you've got a mix of different types, what's the best way to visually find the older ones versus the newer ones?
Nathan, did you want to answer that question in terms of like physically identifying the differences between the cables?
Yeah, so sorry, you were just saying identifying the differences between like Cat5 and Cat6?
Yes.
Yeah, so the biggest difference is, I mean, every cable is going to have labeling on it. You can see kind of right here, there's writing on a cable, and it'll say Cat5, Cat6, if you guys can see me on the screen here. But the other key differences are kind of the internal structure. Cat6 has thicker gauge wires versus, Cat6A specifically has thicker gauge wires than any of the predecessors. And also Cat6, most Cat6 specs have an internal divider for each pair of wires. And that's kind of to help noise on the line. And that's one of the key identifiers for Cat6, is if it has a physical separator for the pairs of wires. If it doesn't have that, then it's probably either Cat6, not Cat6A, or Cat5, 5 or 5E. So yeah. There was also Aaron Braverman had a question about why you wouldn't connect your computer to the router first and then go to a switch. We are going to talk about this a little bit, but I can answer it right now, no problem. Essentially, a router is controlling a lot of traffic flow, but it's also controlling, the routing to possibly. Oh, sorry, Adam. It's controlling flow to the internet, so that can take a lot of processing power, also with firewall rules. So you're just unloading some of the processing requirements from the router onto the switch, so that your devices don't have to necessarily go through a router before they go to one of your other devices on your local area network.
Great. I think that's all the questions we have for now. Like we said before in the chat, if you have a question, please raise your hand and we will get to it in a timely manner, as well as there's a Q&A section for the chat too. So please feel free to use that. I guess you're up next, Nathan.
Yeah, indeed. All right. So it's the same diagram here. We're just going to go into actually how we're going to configure the network with the edge router that we mentioned. First of all, let's talk about the difference between a LAN and a WAN. A LAN is your local area network, which is essentially your cart and your devices connected to your cart. So that's your box IOs, your video router, your computer, and any other devices you may have. Man, again. Got me, Jamie? Thank you. WAN is a wide area network. Typically, when we're talking about a wide area network, we're talking about the internet, but we could also be referring to another local area network that's maybe set adjacent or something else directly connected to your network. It's just helping you communicate between two separated networks. And some of our components here that we need to talk about in terms of identifying our parts here is the most common one is a NIC, which is your network interface card. It's important to note that any device that you have, whether it be a computer or a color box, whatever, if it has more than one port on the actual device side, not necessarily like a network switch, but it'll have its own NIC, its own network interface card. So like the Ethernet port on your laptop versus your Wi-Fi card are two separate devices, logically speaking. So each of those separate devices has what's called a MAC address. And a MAC address is the media access channel or control, excuse me. And what that is that's a unique address to that physical piece of hardware. So that's like you as a person are a unique individual. So is every network device, whether that's your Ethernet port, your Wi-Fi card. So that's just a unique identifier. It cannot be changed. You can't magically become another person. So that's important to know. So next we have the IP address. IP stands for Internet Protocol. And that is essentially like a mailing address, right? You're gonna send information to somebody. You need to know what country they're in, what city, state they're in, what road they're on, and what the house number on that street is. So IP address works the same way in greater specificity from left to right. So here you see 10.10.1.1. So .1 is your house number. So if you're at 25803, that's you, that's your device or that computer or that color box, whatever. So the next thing is that we need to choose a subnet. And what that is that's a kind of a boundary that constrains what is our network. And so we use what's called a subnet mask. And as you can see here, that's 255.255.255.0. And what that tells each device that has an IP address is hey, I'm only going to pay attention to traffic, or rather what I'm going to do is I'm going to assume that traffic coming to me has the same first three sets of the address that I have. Meaning, if I get traffic, I'm assuming that it's coming from the same city, the same state, or same country, same city, state, same street. It's just coming from a different house on the same street. So you can see here, you know, that's corresponding here with our subnet mask. Next thing to note when building your network and your IP addresses with your subnet is that we can create two different pools of addresses when we configure a router. You can configure a static IP address range and a dynamic or automatically assigned DHCP range. One of the key components for doing this that we want to stress is for organizational purposes. If you create a static IP, meaning manually assigned IP addresses for all of the devices in your cart, you can start documenting that, which we're going to talk about in a minute here. But just to keep yourself organized, it's a really important reason for doing this. So just to reiterate, a static IP is a manually assigned IP address that you log into your device and it has that permanently. When I say permanently, until you want to change it, but it's not getting assigned automatically by the router. Whereas a DHCP address is a device, when a device wants to automatically get an IP address, like your laptop or your phone usually does when you connect to your router, that's what's called a DHCP address. And that's convenient for things such as like iPads or iPhones or whatever that you want to connect to your network if you have that capability. We're gonna gloss through this one a little bit. There's a lot of information on this slide. It's just talking about the structure of packets of data that travel on a network. It's essentially data inside of data, inside of data, inside of more data. The key part is that kind of the lowest point is your actual information that you're transmitting, and then encapsulated on the sides of all that are just greater levels of information. Like you're going to stick your letter inside an envelope, and hey, you need a FedEx it, so you're going to stick that envelope inside a FedEx envelope, and then that's going to go to FedEx. So that's kind of your different layers here. The key layers that we're going to be using for troubleshooting anything are going to be these lower three layers: the IP layer, the Ethernet layer, the physical layer, and the physical layer. So that has the IP address is that first layer there, the network layer. And then the next layer constitutes your electrical connectivity with your network cables, as well as the MAC address. And then the physical layer is like, is it actually plugged in? So with that, does anybody have any questions about that quick overview here?
We didn't necessarily have anybody who had a question per se, but there was a request to slow down a little bit. There is one question from Joe Bellac saying, I'm curious about when building an IP address, why use specific numbers 0 to 2255 to say set static IPs like 10.10.1.x? Why choose those numbers versus other numbers besides organizational aesthetic reasons?
Okay, so yeah, to address that, so the range of 0 to 255, its simple answer is that it's mostly for organizational and aesthetic reasons, but it also can get a little bit more complicated if you want to go outside that range. For example, this has to do with how IP addressing works and how that relates to binary. But for any given subnet, if we want to call it that, 0 to 255 is what's available. So you have that much room to play with. But in terms of why we chose 10.10.1, the reason for that was just it's very separate from any other default configuration that exists in other routers or other networks that you might encounter. So it's just very segregated away from those other networks. And that can come into play, like if you're going to be hopping onto an on-set network, like a productions network on your computer, and then your local network has the same addressing scheme, you can get into conflicts where your computer doesn't know which one it's supposed to be talking to. So this way, with just using 10.10.1.x, we're clearly defined, separate from anything else you're probably going to encounter in the wild.
And to add on to what Nate was just talking about, so let's just say, you're on a 192 network, right? If you're connected to another 192 network, you're more likely to run into IP collisions, yes. Another key reason why we like the 10.10.1 is it's so easy to type that in on a camera interface and very simple to remember. So instead of, running the jog wheel to 192.168, for example, typing in 10.10.1 will also assist in speed.
Indeed.
Awesome. Yeah, I just want to comment on that as well. I think you guys already echoed it, but there's a lot of default IPs that come up with devices. Like, for example, exactly, like 192.168, super common on a lot of devices as a default. And so if those pop up, they could cause a collision. You can't have two devices or clients on the same network with the same exact IP address. So just to reduce that and keep it simple, a lot of us use 10.10.1.x. And it's also easier to type into a camera when you're trying to set an IP address with a scroll wheel. But for good example, like Teradek uses 172.16, there's all sorts of like predefined subnets, and 10.10 is just kind of easy for DIT work, if you think of it that way.
There's also one other question from Ben Hopkins saying, for subnet masks, since each NIC has its own, is there any useful reason that you'd want some devices to have a different mask to others on your network?
The simple answer to that is generally no. You want to keep your subnet masks the same. There are exceptions to that. That's definitely more, advanced usage. But that'd probably come in something more like 102 type of a class. And for most intents and purposes on what we're going to be doing as DITs, there's never really going to be a need for that. So. And Ryan asks, why is 192 like that prefix a common IP address? I used to know the answer to that question, but I don't. I mean, there are, in terms of IP addresses, there are ranges of IPs that are reserved for certain things in the global, scheme of IP addressing. There are ones that are specifically reserved for use on your private networks, and there are ones that are reserved specifically for public use or specifically for specific types of services, like voice hosting services and stuff like that. But so 192 is in the space that is reserved for private networks. So there's not a reason why inside of that pool that's reserved for private networks, 192 is so common. I don't know, but there may be a reason.
A lot of consumer devices use that.
Well, yeah, consumer devices use it, but why? I can't remember.
Great. I think that was all the questions we had for the moment. I guess we can move on to Chris.
Yeah, hi everybody. So I'm just basically going to cover, looks like we skipped a step there. There we go. Oh, looks like one of the slides is missing. So we're going to be covering basically documenting devices. So there's a slide missing there, but I'll cover the labeling of the slides. Basically, it's important that all the devices that you have in part of your network, that you also physically label what the device's default IP address, but also what the IP address of the device is you currently assigned to. Also things like a MAC address and a firmware number, or any kind of device IDs, like what camera you're using. For example, on the box IOs you see in the image there, they're labeled what camera is coming in. So the box IO can accept 2 different feeds. So we've labeled it with 2 different types of cameras. Same as your networking routers. If you're always using the same port to be able to label those specific ports, then it just makes it a lot easier if you're troubleshooting, at 2 a.m. in the morning on Friday night, that you can, figure out where a cable's going and what's plugged into. So for example, if you needed to plug, if you're having problems with LUTbox A, you could plug that cable over to a spare port if you're having problems, to be able to help troubleshoot. We quite often use the P-Touch machine by Brother to actually label the devices, because the material comes in different sizes, from 6 millimeters to 24 millimeters, and a variety of colors. For example, black on white or white on black. My favorite's gold on black, or black on yellow. And if you download the application for Mac, which you see the link in the slide there, this allows you to totally custom the way you have that slide representing. So if you just use the printer by itself, it's pretty basic controls. But if I go back one slide here, which it's not allowing me to. Guess we're going forward. So we are missing a slide, but basically one of the other things you want to do is you want to come up with a spreadsheet that basically allows you to enter in all your devices from top to bottom. So for example, you type in what IP address you have reserved for your router. what IP address do you have reserved to your computer, if you're using a static IP on your computer versus a DHCP. Your LUT box, for example, could be like 1010.1.30. Your next LUT box could be 1010.1.31. And every time we statically assign an IP address to a device, it would be within a specific IP range that we've predefined. So for example, if your DHCP manager is above a certain slide or a certain IP address rather, then you want to make sure you use the IP addresses in the lower realm. But also that database will also show you what the default IP address of device is. So for example, if you have a problem with the device and you have to reset it, you want to be able to easily have available what the default IP address of that device is, as well as anything like a username or login credentials that you might need to be able to access the device. So sorry about that missing slide, but if there's any questions, please ask away.
I'm not seeing any questions at the moment. We have two questions. We have one from Isaac, and then one from Zach. So Isaac, you can go first. You are allowed to speak.
Hey, Chris. Hey, any reason you would use a P-Touch over like a thermal printer?
Yeah, so the problem with thermal printers, they're good for like cardboard boxes if you need to, label something like a hard drive you're sending to a client. But the problem with a lot of devices is they generate a lot of heat, and if you use a thermal printer, your label will basically go black. The other reason we use P-Touch again is the surface of it is waterproof, which also means you can use a permanent marker with it if you need to add notes to that device without it getting smudged off with your finger oil. And then later you can erase it with a permanent marker and wipe it off. So it's just a good medium.
Great, thanks.
And then we have Zach, who has a question. So you can go ahead and talk, Zach.
Hey guys, just a question about your networking and routing situation. With my switcher and my router configuration, I have an issue when I'm using a USB breakout Wi-Fi extender for my computer. I'm always running into an issue running all my LUT boxes and like my IP utility, and then still being able to connect to the internet at the same time. And I've tried changing service orders, and I'm pretty sure everything's plugged in correctly, but I don't know if you have this problem as well. It's something that's common.
I can take this, I guess. I mean, it sounds like more information is probably needed to really properly diagnose it, but service order would be one of the first things that I would check. And we're going to cover this a little bit more in our troubleshooting section a little bit later. But yeah, it sounds like service order or potentially IP address conflicts are happening in terms of your subnetting, possibly. But it's kind of hard to say at the moment without, seeing your full setup.
Thanks, Nathan.
Yep.
I just want to mention everybody in the chat window. There's a link, a bit.ly link that has a zip file with the spreadsheet that Chris was talking about. We prepared that as like an empty template for you guys to use. It's awesome to just download it, take a look at it, but also the white papers in there and the keynote or the slide deck. So if you want to follow along, super helpful to download that.
Great. I think that answers that. Nobody else has any questions or anything like that. So moving along.
All right, that's me, I think. So what we have here, we're going to do, pause that real quick. So I just got a video that we're going to roll through here of setting up an actual edge router. So without further ado, let's just go through that and I'll just show you what I did. First thing that just happened is that I just turned off Wi-Fi. So we're just going to physically connect to our edge router. And if you guys can see me here, we are going to connect to the edge router on the port 0, the leftmost port on here. And this is important because when the edge router comes out of box, this is the only port that you can actually communicate with the edge router on. That changes once we've got the configuration up, but for the moment, plug right into port 0. So then we go into system preferences and go to network settings, and we will need to manually assign an IP address for our, well, for me, I am using a Thunderbolt to Ethernet connection. And right now what I'm about to show you is that, hey, I'm just powering up the edge router. It's not fully booted yet. And so what happens that then it knows that it's connected. There's an electrical connection, but it doesn't have communication with it yet. So what you see here is you see this IP address of 169.254.243.157, and the text right above it here, you see that as a self-assigned IP address. This is what happens when your computer or your device is expecting to automatically get an IP address from a router, and it's not. And this is an immediate kind of red flag that if you see a device that has 169 as its starting IP address, that immediately tells you it should be getting an IP address automatically, but it's not. So that's just in terms of diagnostic things and things to look out for. But as you'll see, as it finishes, or sorry, we have to manually assign it. So we're going to give it 192.168.1.24. And the reason for this, I did that, of course. The reason for that is that the edge router comes pre-configured with its default IP address of 192.168.1.1. So let me let this catch up here real quick. Sorry about that.
This is going to be a common thread with every device you set up in the future, guys. The device comes with its own IP address, and you'll have to switch your computer over manually to be able to talk to it, and then you can make your changes once you can access the device.
Absolutely. Just about everything. Sorry, I would just fast forward, but the slide controls are right under the video here. Apologies.
And Nate, I think this is a really good time to mention that the majority of routers will sit at a .1.
Yeah, absolutely. So that, yes, what Ryan said, just about any router, whether it's 192.168 or 10.10, whatever it is, the router is going to be, its address is going to be .1. Another key thing that I just hit here that just kind of glossed over is you gotta hit the apply button. A lot of times people will put in this information and then they'll go over and do their next thing, and they didn't hit the actual apply button. So those settings didn't actually take. So even though this interface up here, this goes green and it says, oh, hey, you're good, you're not actually good because you have to actually hit apply for the changes to take effect. So next we actually go into our browser window and we type in the edge router's default IP address, 192.168.1.1. And here is important, this is an SSL warning saying that your connection is not private. You guys have probably seen this before. And it's important to note that Safari will not handle this well because there's not an easy way to bypass it like there is in Chrome or Firefox. So here we just hit show advanced and then proceed. Default username and password for the edge router is just UBNT and UBNT. And then we're gonna go ahead and do what this pop-up here is asking, go to a setup wizard, and we're gonna take us to that wizard where we have here the Ethernet ports, the internet port configuration. And then you don't really need to change anything on this first window here. So we're going to move down to the LAN section where we want to make sure that the one LAN box is checked, and then expand down the LAN ports. And this is where we're going to change our subnet for our network. And we're going to make it our 10.1.1, make sure DHCP server is enabled, and you can give your router a new password, or if you want to change the username, you can create a new user, put in all those new credentials, and then click apply.
Hey, Nate, if you don't mind pausing.
Not at all.
Yeah, so Joe Bellick asked us about this earlier. This is where we're setting up the DHCP server on our box right now, on our edge router. You can make that number, the subnet, whatever you want it to be, but that little window is exactly where you tell it, okay, I'm choosing this range, this starting range subnet. So that's an important thing to see. And you can see right now, frozen, that the router is now going to switch from 192.168 to 10.10.1. So you have this control when you're setting up a DHCP server for the first time.
Yeah, and we're also going to talk about a little bit more control over the DHCP server in just a minute once, as we proceed here. This dialog that you see right here is really important to note, and a lot of guys miss this, is that we have just changed our IP address because we did just log into it with 192.168.1.1, but we've now just changed the IP address to 10.10.1.1. So two things have to happen with the edge router, is that A, you have to now move from port 0 to one of the other LAN ports here. So we're gonna, this is already done because it's a pre-recorded video, but boom, switch it over. And then once it reboots, you'll actually be able to talk to it. You will not be able to talk to it on Ethernet port 0 anymore because that's now configured for the internet port. So, damn it. Sorry. I wish we could move these controls. Is that too far? A little bit. Oh, good call.
So guys, I just want to touch on for a quick moment about the idea of what we're currently doing here, just to kind of relate it back to what's actually happening for your cart, right? All of this talk about the DHCP server, some of you who may have not heard about that, basically what it is, and we mentioned this earlier, is that the first 100 values in your subnet range, that's what's going to be reserved for static IP addresses, right? This is where you're going to pin down your things for easy tracking. Anything above 100 is reserved for the DHCP server. What that means is it's just this area when someone joins your network just temporarily, they'll be assigned an address in that space. One of the most useful allegories for me to describe this is if you can think of it like when you walk into an airplane and first class, they have reserved seating. And in the back, it's just sit wherever you want to, right? That's essentially what Nate is setting up here in the web browser. The DHCP server is going to allow for people to enter the network and just sit wherever they want for the time being. Everything else belongs to you. You know where it is.
Yeah, and we'll actually see that configuration process here in just a second. So while that reboots, a way to check, hey, when is this coming back? There are a couple good things to use. You can use terminal, and also I have system preferences open. So I'm going to use the ping command, which we'll cover in a little bit more detail here in just a little bit. But you use ping and then the IP address, and as you can see over here, it's pinging and it says, hey, there's no route to host. And the other thing we have to do is change back to DHCP, hit apply, and then when the router actually comes up, you'll see that we'll automatically get an IP address. So here in just a couple seconds, you can see that.
And just so you guys know, ping is it's a program that's just going to send packets to the address that you give it. So we address it to the edge router's new address. And so it takes the edge router, like 90 seconds to reboot and start up the server?
Yeah, it sounds about right. And it's sending what's called an ICMP packet, which is the most rudimentary packet. And all it's just saying is, hey, are you there? Hey, are you there? Perfect. And now, as you can see, it is now responding. And then to cancel the ping process, you use Control-C in the terminal window. And now we'll go back to the browser to finish our setup. But now we have to put in 10.10.1.1. We'll get this SSL warning again because it's a new address. We log in with the new username and password that you set. And then the first thing we're going to do is we're going to go over to the services tab, which you'll see right here. There's a lot here that you could get into, but for the moment, we'll just go to services. And right here is DHCP server. Select the drop down, and you can select any of those three options, those top three options, which were leases, static mapping, or details, gets you to the same window. You can see here that I've received an IP address automatically. This is DHCP leases, meaning it's something that the router has automatically given to a device. Oh my gosh, I keep doing that. Sorry, guys.
I guess it's useful to point out too that when Nate switched over from manual address to DHCP, nothing was happening until the edge router rebooted. Once it's
Yes.
rebooted, it starts up a DHCP server that we just pre-configured with the what is it?
10.10.1.
No, it was like a little wizard that we used.
Oh,
so
yeah.
so
the basic
basically
wizard.
now on the edge router, there's a DHCP server running, and we're going to show you how to get deeper into configuring it. But basically, Nate switches his computer over to DHCP and says, "Hey, I'm ready for an address." Whenever you're rebooted and you're running, and the edge router gave him .38, but we're about to change all these settings, and you'll see why.
Yeah, so this comes back into the organizational setup, that we were talking about, just keeping your stuff separated, whether, that's all your items on your cart, if you want to keep them nice and separated. So we're just going to create a lot of room for creating manual addresses, giving it the first 100 addresses. And so we set up that DHCP server so that the automatically assigned addresses start at 100 and can go all the way up to 254. So you have a lot of room for automatic, and you have a lot of room for manual addresses as well. Quick thing, lease time here that you can see over on the right. Not super critical, but that's just telling you how long that device can retain that IP address before the router says, hey, we're going to give it a new one, which could possibly be the same one. But, there's not super critical, but that's just a thing to know.
Hey, Nate, just to comment on that, for anyone wondering about lease time, it's done in seconds. And so if you want to give a device, let's say someone's iPad, if you're on a show for 6 months, you can type in, the seconds that equate to 6 months. And as long as anyone joins your wireless network, which we'll cover later, they'll get the same address because it's a lease. It's just like a car. You basically own the right to that address for the duration of the lease time. Like, let's say after 6 months, that person doesn't hop on your network anymore, the DHCP server will make that address available in the pool again. So the reason why we're separating, any device above 100, we don't have to worry about any of those addresses. This just takes care of it.
Indeed. So now you'll see that there are no leases assigned, and then we're going to go back to system preferences, and you can see that now we have a new IP address in that same range. And now something that you can do is you can create a static map. And you can see right here this is kind of in line with what Jamie was saying. This is another way to kind of handle that same thing. If you always want a device to have the same IP address, you can do what's a static map, where it takes the MAC address, the unique hardware identifier of the device connected, and make sure that hardware device always gets the same IP address. And you can give it a custom name if you want. So I'll do that. This one. And you'll note that here in a second that here it won't accept spaces. So you'll need to make sure that if you want something in there, you use an underscore or whatever. Then I think we're going to move on to connecting to the actual internet at the same time. But now you can see this in the static IP map list.
Nate, one thing to add to that too, just so everyone understands, if you guys assign a device a static IP address, your router is not aware of that address. It can work on the network just fine, but if you statically assign it inside the edge router settings, now the edge router is aware that there's an address in its pool that is reserved. So there's static reservations, and then there's DHCP reservations. There's different uses for all three.
Exactly. And we are getting close to the end of this section here. So if we have questions, we can get on those in just a minute. So now we're going to actually turn our Wi-Fi back on. And then if you want to connect to production's hotspot or the camera house, wherever you studio, whatever, you select your network. And now it's important to note, this is where service order is critical, because as I'm going to demonstrate, now I'm going to try and go to Google, and I'm going to get this. So you're like, wait, I'm connected to the production's Wi-Fi. Everybody else can connect to the internet. Why can't I? And you say, okay, so here's this thing called service order. And if you see this, you have different network devices that are all listed here. And this is actually the order in which the operating system is going to look for the internet, essentially. So Wi-Fi was all the way down at the bottom. We just take that, drag that all the way up to the top, and then hit apply. And now if we go back to our browser, try Google again, you'll see that we'll get that right away. Not just a cache page. Boom, done. So that brings pretty much this section to a close. Yeah.
We do have a couple of questions.
Yeah, absolutely.
Great. We have, I believe it was Gabe asked, if you switch to a different computer, how would you quickly configure and connect to network and router?
Switch to a different computer. So in this example, yes, Jamie, I can, is the answer to your question. Sorry, back to your question. It's pretty easy. You just plug in your next computer, and if you've got a DHCP server running, then you can just make sure that your network settings are set to DHCP. Then you can connect, and then if you want to connect to your router, you can just type in the router's address and you can log in. So at that point, you should be, at bare minimum, you should be on the network receiving a DHCP address. If you're going to plug into some other network that maybe doesn't have the same IP addressing scheme, that's one of the reasons why you would use DHCP in network settings, just to make sure, hey, can I even talk to this network at a basic level? Does that answer that question, I hope?
Yeah, so Gabe said yes, it did. Okay,
Okay,
and then Tamar says, do you have to configure your computer address too, keeping it static or not?
That is a point of preference, but if your machine is going to be in your DIT cart, it would not be a bad practice at all. In fact, be a good practice to keep your IP of your computer statically assigned, just so that it's fitting within your organizational system, you know, as you want it to.
We're trying to recommend that any device that you need to regularly access, whether it be LUT boxes, routers, computers,
Exactly.
statically assign them an address, keep track of it with the spreadsheet that we're going to show you. It removes any variables. You know what I mean? As soon as you give DHCP to a computer, the address of it can change. There is a possibility of that depending on lease time, and then you won't be able to find a device easily. So it just makes sense. It reduces a lot of variables, just making as many things static on your network as possible.
And Jamie, I want to contextualize that for something that might happen on set. So let's say that you power down your system and something like your LUT box, which should have a static IP address, is sitting on is getting a dynamic address. If you power cycle your stuff, there is a chance for that LUT box no longer to have that address. So that means opening up LiveGrade and then your devices won't be there at all. So that's kind of the key reason of wanting to pin down your devices so you can stack and track them real easy.
Excellent point. Yeah, if your LUT box changed its IP address, you'd have to go back into LiveGrade and then find it again and re-enter that information. So why do that? Just keep it static.
Okay, Joe Belloc asked, I didn't see your config of the static range of IPs. Is that automatic because you limited DHCP? And Jamie, you said you wanted to answer that.
Yeah, so Joe, in the edge router setup, when you get into the DHCP settings, it gives you a start range and an end range. Nate, do you have a way to show that? I think you do, right?
Yeah, I can do that.
Yeah, we're going to show that, Joe, because the idea behind it is it's the DHCP range, right? So the dynamic leased IP addresses. Where do you want, if you have like .1 to .255 available to you, how do you want to separate that out? And so our thought process is everything from .1 to .100 is static, right? That gives you 100 devices, or 99 if you're really picky about it. Anything above 100, so 101 to .254, is reserved for like people joining your network with their iPads to watch like a video stream. It's the part of the network you don't have to worry about because IP addresses are going to get leased. They're going to come and go. You don't have to worry about it. So we're just kind of like on a very simple way, like making two different pools of IPs, and it's just an organization tactic. Does that make sense?
Yeah, and I can show that here in just a second.
There you go.
Sweet. Stand by.
Ben Hopkins will get to you in a second.
Okay, so here is the dashboard, and when you come back in,
We just want to point out too that most of what you guys are going to need when you're just getting started is in that services tab. Everything else is really like above and beyond what you're going to need on set, but eventually we'll get there.
yeah, so back to your actions tab right here. So yeah, if you go to details, this is essentially saying what is dynamic. Everything outside of that is going to be static. So everything between .1.1, which is the router, as you can see right here, and up to .99 is available. So 2 to .99 is available for static. This router will not do anything with those in terms of sending addresses or not. So it just keeps those out of the dynamic pool is what's happening. So there's not an explicit, these are static IP addresses and these are dynamic IP addresses. It's just, here's what we're going to dynamically assign. Anything outside of that is fair game, is what's being said there. So, let's see, Ben Hopkins. Is that the only function of service order on the Mac? That is the primary function of service order. There is some nuance to that, but probably not anything that you will ever need to encounter. Minus possibly that USB issue. I can't remember who had that. If that was you, Ben, but yeah, it's pretty much just to say in what order is traffic going to be prioritized. So if your first one has a gateway and that gateway can't actually talk to the internet, then you won't be able to get to the internet. So like your Ethernet network is going to have a gateway that's talking to your edge router that's not talking to the internet. So it's going to use that gateway as its first order to try and get to the internet, and then it'll go down to your Wi-Fi, and that has a gateway that can get to the internet, but it's already hit a gateway to your edge router. So then that traffic just dead ends. So that's why service order is there. It takes those things in order.
Definitely, it's part of troubleshooting as well, which we'll get to later. If things aren't working, just check your service order. It's one of like the most easily overlooked things when you're hour 12 into an overnight shoot and you're just stressing out. Just check service order. It will fix a lot more.
Yeah, just double check it. Yeah. John, and it looks like a couple of people are asking, wondering about the /24 on the subnet. And you can see that right here.
Question.
So this is just a different notation for the subnet mask, which, as we talked about before, is 255.255.255.0. So essentially, a subnet mask IP addressing, it's all just binary. So each one of those, not to go in too deep here, but each section of an IP address or a subnet mask is a representation of 8 ones and zeros. And so 24 is just saying the first 24 of those digits are as a 1, which means if you change that to decimal, that equates to 255.255.255, and then .0. So if you were going to be, you can change that to any other numbers, and that gets into more complicated subnetting that we'll never ever need. But 24 is what you should expect to see if you're going to see that notation.
And guys, check the white paper that we shared in the zip, because we actually break this down. It took me a while to figure out what /24 meant. And it's funny, people get tired of saying 255.255.255, that they just say /24. Because again, to Nate's point, in binary, /24 means the first 3 sections are all ones, because those add up to 255, right? And then the last octet is 0, so it doesn't get added up. So you actually have 3 sections of 8 ones, which equal 24. Maybe we could show that later, but in the white paper, it's documented. And it's something that when you see it, now you know. And you can actually see that expressed as /16, which would be 255.255.0.0.
Yeah.
Just a pro tip there.
Jamie, Adam had a question about the Ethernet 0 port.
Yeah.
Yeah.
So just to reiterate what Nate was saying, and to answer Adam's question, when you're setting up the edge router the first time, your computer needs to be directly connected to port 0, ETH0. Once you set it up in the way that we showed you, that in that wizard, port 0 is then going to be reserved for incoming internet. So you want to unplug your computer, plug it into ETH 1, 2, 3, or 4, and then you'll be able to use it as a regular router. Does that make sense?
Yeah, and he was specifically asking how you bring internet into your router. And yes, you could hardline. If you don't have that option, like you want to get your network connected to production's Wi-Fi, there are ways to do that, and we could talk about that using wireless bridging. That's definitely, we're definitely going to get into that in 102 and all things, wireless. But yes, the simple solution is just a wired into Ethernet 0. Gets you
Production hotspot router with Ethernet on it. You can plug it directly into port 0, and then your hardwired network will have internet. Yeah.
Great. And then Zach had a question saying, curious about using just a gigabit desktop switch versus an edge router. Is this the only difference between is the only difference the DHCP that the edge can perform? Is this covered later in the course? You can wait.
Nate, you want to cover that?
Yeah, sure. That's not a problem. I mean, in this particular example, yeah, pretty much you're just using the edge router for DHCP to be able to have something that will automatically give out IP addresses to devices that either you can't statically assign or it's not particularly convenient to assign, maybe like iPads. It's not that hard, but you also don't want to have like your phone necessarily on a static IP address all the time because it's just inconvenient. So it's definitely a convenience factor just to have the router there. You can absolutely run everything we're talking about, your box IOs, your video hub, your computer, all with just a switch, no router necessary. Absolutely. That just doesn't give you the option to eventually connect your local network to the internet. But yes, if that answers that question.
And then Tamara is saying that maybe I'm getting ahead of this, but if I wish to connect to production Wi-Fi and use internet and also use a router to connect cameras to my cart, would that be using my service order to have the Wi-Fi connection prioritized, compromise my camera connection? That's something we'll cover in the wireless in 102, if I'm correct.
Yeah, more or less, but I mean, we that's a kind of a service order question, and sure. The short answer is no. It shouldn't. The only caveat to that is with if your subnet range is the same as productions, that's when you can run into problems, which again is one of the reasons why we chose 10.10.1, because it just eliminates the possibility of running into subnet conflicts. So I have had that exact problem early on where I configured at 192.168.0.x for my network, and then I connect to productions network, which is also 192.168. My service order is set correctly, but those two IP address ranges, those two subnet ranges are the same. And so that's just an extra layer of confusion for your computer.
And you also can't have two DHCP servers on the same network. So it's just going to create a whole bunch of headaches. Another reason to stay away from 192.168.
Absolutely.
And then John Waterman says, if you have three computers that you want to swap between, would you set them each with a unique IP address or share an IP? Can you have a single IP address reserved for several MAC addresses if you know only one will be connected at a time?
So the answer to that is, to the last question is no, because when you are reserving an IP address, it is specifically using the MAC address as an identifier for which to hand out that IP address. So if you connect even over Wi-Fi versus Ethernet on your laptop, even though it's the same computer, those two things have different MAC addresses, so they will get a different IP address. And so your question about swapping between three computers, best practice would be to give them a unique IP address so that there's definitely no overlap, no conflict. Or if you want to be safe, you can set your computer to be in DHCP, at least initially, just to make sure that you're connecting. And then if you want to statically assign, you can do that afterwards. Once you know where all your network settings are. Like if you're going to hop into somebody else's cart and you want to know what the static pool is, you can then say, hop in here, because the person you're covering for has left you a spreadsheet that says, hey, here are all my IP addresses, and here's where I can fit my computer. So, yeah.
Great. I think that was all the questions that we had.
Sweet. And whoever wants to, okay, it looks like Kyle's going to do it.
Just one quick caution. Jasper Varakin just brought up a point, just so everyone is aware. If you are using PoE to power this router, the ETH4 port will loop that power out. So be careful not to plug that into any devices that might, not like that power.
That is configurable. So
Yeah.
that can be on or off. But just in terms of that, it'll only pass through the power. So I did confirm this. It will not take the regular 12-volt input and put it out through that PoE port. It is only pass through. So it'll only work if you're powering the router via PoE.
Got it.
Great. And with that, I don't think we have any more questions. We can move on.
Sweet. So I think that means, oh, we did all this. Sorry. Stand by. You just take we're going to see, Kyle's going to show us a little bit more about LAN-scan here in a minute, but this is just kind of a picture of what LAN-scan might look like. If you open up that software and you scan your network, you can see all your devices and with their corresponding MAC addresses and their manufacturer name. So you can see the Z-Link is actually a box IO, and you'll start to recognize these things as you use LAN-scan. If you have the paid version of LAN-scan, you can actually pop in your own custom host names, because some devices won't actually give you a host name automatically. So with that, I think Kyle is up.
Hey guys, how's it going? So I'm going to be kind of talking more about our approach to setting up all the devices on our network and our best practices to make sure that we don't run into any of the issues and start banging our heads against the computer because something's not connecting. So the first thing that I want to make clear for all you guys is our best practice is always going to be to attach one device at a time when we're bringing them into the network. So the whole point is just to troubleshoot, remove all the variables, just like we do on set. If something's going wrong, check your air gaps first, work your way down the cable, and then go into all the other stuff. So let's go on. So first things first, initial setup, you're going to want to put your Ethernet port onto DHCP, and that's just telling it to look for any IP address that the device is going to hand over to you. Very first device we're going to talk about here is going to be the color box. Now the color box is a little bit interesting in the fact that it has a DHCP server on the device, and we're going to utilize that when we connect it over USB. When we connect it over USB, it's going to give us a static IP address, and we'll get into that here shortly. But before we start going into this, I just want to go back over this list we have here. So this is a rough outline of how we would want to have our network look and assigning all those IP addresses that we want to do for each device. And we're going to use this list when we're giving out all these IP addresses to the devices as we go forward. All right, so first up here, I'm going to show you guys a quick video of me setting up a color box. When you connect the color box over USB, when you're in your network settings, you'll see the color actually pop up there. The first thing you're going to want to do, though, is you're going to want to change the service order so that that thing is right on top there, so that you're not going to have any interference from anything else on your network. So once you select that into service order, you're going to move that up to the top there. It's going to say OK, and then you noticed right when we did that using DHCP, it went green and told us that we were good to connect. So once we're green and we're good to connect, we're going to go ahead and put in that IP address. And this is an example of a web interface for a device. All the devices that we kind of use will all go through kind of the similar steps and processes. But for this color box here, when we get into network settings, we're going to go down to Ethernet settings, and we're going to want to go ahead and select static. And when we're in static here, you'll see that it was originally defaulted to the default password that the device had. So here we're going to enter in our 10.10.1 X number for this demo. I think I did, I gave it a 5 or a 6. Let's see here, playing that.
I think you did 6.
I did 6, yeah. There we go. Someone clicking on me. There we go. So 10.10.1.6. And then we want to make sure that .7. Oh, fun. So you can pretty much do whatever you want for your own IP addresses there, but you want to set your gateway to look back at your router, and that's the 10.10.1.1. And the DNS server, that's more for online and camera control, but for this, we're going to go ahead and point that to the router as well. So once your settings are set, you're going to want to go ahead and refresh, and that's going to tell you that it's connected to your network, but we're going to verify it by using LAN scan. So LAN scan was briefly talked about, but it's an amazing tool. It basically just gives us a back-end view of everything going on our network. And it's my verification tool to know that our device is actually working and talking before we go to the next steps of trying to hook it up to our software. So then we're all set up there. When you remove that USB cable, you'll realize all of a sudden it's now disconnected, but that's okay, because now it's actually connected to our router. So if you want to talk to that device again, you're going to have to put in that IP address. But for now, I'm going to go ahead and add this to LiveGrade for us.
Kyle, just to be clear for everyone who's watching, we just used USB over Ethernet to set up the device and give it a static IP over the Ethernet port on the color. And so now we've connected the color to our network with an Ethernet cable. Just so everyone knows, the USB was just to set it up, and now we're at full Ethernet for the rest of the operation.
Yep, that's correct. And as we're going in here to add the device, you guys will all know this, that LiveGrade's pretty awesome about being able to auto detect LUT boxes on our network. But if there's ever a case where it's not popping up for some reason and you're seeing it on LAN scan, then it's probably a software issue with LiveGrade. I've had this happen a couple times where a color box hasn't popped up. In those situations, I know the IP address because we set it as a static, so I would enter it there under custom IP. But for this, it popped up fine and automatically. And now you'll notice you have the green light, which means you are connected and you can go ahead and start using that LUT box on the network. And so yeah, that is our color box, guys. Oh, and I'm just demoing real quick that you can't connect to the color box over that 1920 by the USB IP address there. So we'll want to go ahead and enter that static IP address that we gave it, and that'll give us our that'll give us our control of the LUT box itself. Awesome.
Common mistake when people change settings, you know, the default or from the default IP address to something that they've now assigned to their network. Common mistake is forgetting to change the address in your address bar to the new address. So one thing just to remember when you guys are waiting for the page to reload, just check the address.
Great tip. And so here's a couple slides just outlining what I just went over, but this is a visual. So that USB port, that's what you would want to connect to your computer when you're initially setting it up. And that is the IP address that will be displayed on the device when you're connected over USB. And going through all the network settings, just like we did, apply that, you'll see connected and add your device. Any questions on the color box setup before we move on to the box IO?
I think it's useful to point out, just so everyone's seeing, that you actually can set up the color over Wi-Fi. So if you wanted to like log in with your phone over Wi-Fi, you can change all these settings for Ethernet. And you can also change your computer to 192.168.100, I think it is, let's say 2, and then connect over Ethernet. So there's 3 different ways to go about setting up the color initially, just so people aren't confused.
Yeah, definitely. You guys will realize this, especially with how we work on set. There's many different ways to skin a cat. I always feel like the USB is kind of the most straightforward way of approaching it. But yeah, there's definitely many ways to get this all done. All right, now we're gonna get into the box IO. So the box IO also is very similar to the color box in the fact that there's a couple different ways that you can connect it to your computer for the first time. It has a built-in Wi-Fi with that you could connect to it that way, but we're going to demo just connecting it straight over Ethernet directly into your computer. And I just wanted to stress this for you guys. The first time you set this guy up here, you do not want to plug it into your switch or your edge router, and you want to directly connect it to your computer. And I'm going to show you guys why that is here shortly. Quick little point for you, these box IOs are really amazing. I highly recommend them. I'm sure a lot of us already use them. And here is the demo for the box IO. So when you first connect your box IO over Ethernet to your computer, you will notice that 169 IP address that popped up that Nathan discussed earlier, which is basically a non-DHCP served IP address to the computer. So what we're going to want to do here is manually enter an IP address to make the computer our DHCP server for this device so that they can begin talking. So where it says configure IPv4, we'll want to go ahead and change that to manual once this video catches up to me. There we go. There it is. All right, so now we're going to manually set in this IP address. Real quick, I want to point out that the default IP address for the box IO is 192.168.1.244. And you can see that there in the IP remote utility as well. So what we're going to want to do is we're going to want to give our computer an IP address in that 192 IP range. And we're also going to want to move our subnet mask to 255.255.255.0. So everything is talking on that same pathway there. And router, I just like to pretend like we're going to a standard 192 router as well. So I will give it the 1.1 address and then make sure you press apply.
One good thing to note here, guys, make sure if you're trying to connect to a box IO, you don't give yourself the same IP address as the box IO. You can't have two devices or clients, same, on a network with the same IP address. So if you typed in under IP address .244, there would be conflicts and you just wouldn't be able to connect to it. So just remember that. You can make it 243 if you want, but just don't make it 244.
Definitely. Thanks, Jamie. I want to point out one other thing here. If you look down on LAN scan, I had this open and it scanned the network for my computer with that device connected to it. And you notice how that IP address was set to the 169. After I pressed apply there and I made our computer have a different IP address, our LAN scan will then update with the new network settings. And if we did this correctly, you would automatically see our box IO come up on LAN scan when I scan it again here shortly. See, LAN scan asked to update our IP that we just changed. Then I'm going to run it again.
Can't stress it enough. Everyone should be using LAN scan. It takes the mystery out of your network.
It's a great tool.
And there we go. So you guys see now that that box IO pops up and it has that default 192.168.1.4 IP address. So we're going to use that information to connect the IP remote utility. Luckily, the first time you set this up, it will automatically have the default IP addresses for your box IO there. But I found that if this is your third or fourth box IO you're setting up, you're going to have to manually input that IP address for it. So once you connect, boom, you're in. You know you're connected. So we're going to want to go over to settings, and we're going to want to put that IP address, that default IP address, back to our router configured IP address. So it's going to be the 10.10.1.6 is what I'm going to designate it for this demo here. And then the next steps there is, we want to make sure our subnet is still on the 255.255.255. And then we want to set our gateway to be the same IP address as our router. Just trying to navigate everything to go through the same door, which is our edge router. So once that's set up there, you noticed, if you notice there on the left-hand side in the network settings, our Box.io has now disconnected from our network because we had already created that DHCP server with our computer. So now we're outside that range and it disconnected. And you can also verify that by looking on LANScan as well. So it's completely disconnected. So at this point as well, guys, we're gonna wanna go ahead and connect the Box.io into our switch that is connected to our edge router, putting it on our great new network that we just built out. So that is that Ethernet EN0. That is our edge router network that we just connected to it. And I just plugged in the Box.io to the switch. So when I do this scan again down here on LANScan, we should see it pop up in the 1010.1.6. And there we go. So you see how we have our, I already had the video hub connected and I gave that the 1.5 address. But with the Box.io specifically, they don't give us a host name. So I'm in the habit of labeling that host name. So I would name, if I was on a show, I'd label that my Box.io cam A or cam AB or give it a number, whatever you're tracking that you want to give it. It'll always sync up to that. So disconnected there. We're gonna input that IP address we just entered there. Verifying that it's on LANScan. We're gonna label it. See that there? And entering in that IP address. The great news, guys, is because we're entering these IP addresses in so many times, it also helps to memorize it, especially when we're under pressure on set and we're trying to troubleshoot. The fact that we're giving all these things static IP addresses, it kind of just helps speed along our troubleshooting. Like for instance, like, oh no, I come back from lunch and my Box.io is no longer connected to LiveGrid. Okay, I know exactly what number I can ping to see if it's on my network. Maybe something got unplugged, maybe there's a power issue. But those are the types of things that allow us to move quickly and troubleshoot and keep organized, because we all know how important that is. So now I'm going to demonstrate bringing the Box.io into LiveGrid and specifically the different channel modes that we have. So the Box.io is great because you can handle 2 cameras on one box, but you got to configure them differently for 1 camera and 2 camera. So I'm going to show you first how to add the Box.io as a single camera device. So in LiveGrid, it doesn't automatically find the Box.io like it did with the color box. So here we're going to have to enter in that IP address that we just gave it, the 10.10.1.6. And then we're going to add. And it will pop in. And we got the green light there, so that means we're all good and connected. Now, for you guys, when you're trying to switch over to dual channel mode, what we'll need to do is we'll need to go into the IP remote utility, and we're gonna select dual channel mode. But first, I just wanna point out to you guys, if you're in single channel mode, your LUT size will always say 33. And if you're in dual channel mode, your LUT size will say 17. So that's another little giveaway there for you within the LiveGrid of what your current settings are. So when you go into dual channel mode, the box is now switched over. And then under LiveGrid, you'll want to just go and hit reload devices. And what you'll see right away, the labeling on that device has changed to channel 1 and a 17-point LUT. So now we're going to want to add the second channel to a new slot. We're going through the same process there, but now we're going to get a different pop-up here. And when this new pop-up is, we're just going to add the other channel that we're missing. And now you have 2 populated channels with 1 Box.io. Now there's another way of setting this up. So if you're setting this up for the first time and you just want to have 2 Box.io, you want to have 2 slots working off that 1 Box.io, you can actually add them both and LiveGrid will auto-populate. both channels with that option right there. And I'll show you guys what that looks like. Boom. And it clicks in. So now you have a Box IO functioning with 2 independent channels that you can grade on. And that's that for the Box IO, guys. I'm going to quickly go through some additional bullet point slides. And hold on. Oops, I don't want to do that. We're going to go to the next page.
Kyle, I do have a quick note to add about the Flanders Box IO utility. Just a reminder, if you guys haven't got it yet, it also comes in an iPhone app. So if you have a kit phone, give your kit phone a static IP address, and that's another way to quickly manage your Box IO for whatever reason if you don't have a laptop to interface it with. Just another option of doing things.
Definitely. The Box IO utility is great. Download it from Flanders. They update it often, so just kind of try to circle back and check on it. Yeah, and just going through the steps of adding the device and going into dual channel modes there. What's awesome, guys, is if you've had a previous version of this IP remote utility, they before used to not update the IP address that it's currently set to on the box in this window right here, where it says change IP address. So now if you guys update to the latest version, it'll tell you what IP address the Box IO is actually set to, which is a huge little feature for us. And we're just going to add that through and adding the boxes. Oh yeah, and the O ship button in case your Box IO goes hits the bed and you got to reset is you just need a little pin, and it's right there on the 2 SDI input side right there. Any questions?
Yeah, I think Gabe has a question. The best approach for jumping from setups using colors on a cart via Ethernet. On a smaller rig, I have 2 separate colors and I connect via USB. Is it just a networking setting change needed on the laptop? And Jamie, you said you want to answer that.
Sure, Gabe, awesome question. A lot of us have multiple setups and this question comes up all the time. We discussed how to kind of cover this, especially if you're looking at the diagram that's on here right now. If you're using, let's say, like the same edge router, like an edge router X on both setups, then you can just reserve a static IP through the settings, the services for your laptop, because it's based off the MAC address, right? So the MAC address of your laptop's never going to change for the purposes of this class. So when you go from one network to the next one, it will always have a reserved address depending on which router you're connecting into. In your setup, if you have colors, you're using colors for all this kind of stuff, I would maybe personally want to group them as like the first 2 are .4 and .5, and then on the mobile rig, .6 and .7, just to keep things separate, and it keeps you from getting your wires crossed. Does that make sense? I think so. Kyle, I was also going to point out for everyone that's watching too, I think a lot of what we're going to be doing is very similar, for any device that you want to join to your network. But we keep stressing, like, take the time when you're setting it up, label the device with P-Touch. I mean, even in the worst case scenario, use paper tape and a Sharpie, but just be methodical, label your devices, jot it down in your spreadsheet. It's going to save you so much time when things are going wrong and people are standing over your shoulder and they want to see something and you're stressing out because your network's not working. Label your devices. It makes everything so much easier. And we've also discussed this as well. Like, say you're sick and someone needs to come in and replace you midway through the day. That person covering you should be able to open up your IP list and see how your network's set up, run LAN scan, and they should be off to the races. So it's really important. It takes a few seconds to do that kind of work, but it saves you the headaches later on.
Oh, it looks like Ben has a question or a comment. He said, I believe if you get your Box IO setup info from Flanders, they will have you use built-in Wi-Fi out of the box to connect first and set up your Ethernet. I've had trouble with this many times because I forget how they program that, which is not what I'd expect. Can you speak to that? Yeah, definitely. Like we were saying earlier, there's many different ways to skin this cat. Introducing Wi-Fi and service orders, you can run into some conflicting issues connecting to it, but it still gets you to the same end result. I'm suggesting that everybody connect directly over Ethernet. to keep everything consistent and methodical. When you go over Ethernet, you know for sure that you're having a connection. Wi-Fi, same thing. They say their Wi-Fi is out.
Yeah, Ben,
Oh, yes.
just to add to that too, there's a reason why this class is just hardwired and the next class we plan to offer is wireless. Wireless is just, it opens yourself up to less predictable results. I think the best thing when I'm taking a new device and I want it to be on my network, just directly connect it to your switch or to your computer and just set it up directly. Like reduce the risk of trying to use Wi-Fi unless you absolutely have to. It will work, but it's just so much cleaner just to connect an Ethernet cable, set it up, and then it's ready to go.
The other point there as well is to make sure that when I generally get new products, I do a factory default right out of the box. Also, if there's any software updates, it's a good time to do that before you set up all the IP addresses.
Definitely. Good tips.
I don't see any other questions, so I think we can move on.
All right, Jamie, then you're up.
Awesome. Thanks, guys. So we're going to start talking about like the most essential piece of gear on our carts, at least in my opinion, is our video router. I'm focusing on the AJ Kumo, the 32 by 32. It's super simple to set up. At this point, we've seen a color box and a box AO. It's very, very similar to the same kind of thing. And I think sometimes people might get kind of confused, right? It's just keep it simple. Like the Kumo has an Ethernet port on it. You can connect your computer to it. It's if you bought this secondhand, it's really great. Just do a factory reset. Just wipe out what anyone has done to it because you just don't know, and it removes any variables. And then you can get it. You can log into the web UI and start setting things up, which we're about to show you. Just bear in mind when the Kumo boots, the only thing that's a bummer about the Kumo, it just takes a little bit longer to show picture and about 1 minute to gain network control. So just keep an eye on the blinking lights on the front and be patient. There's the default IP address. So if I was going to set this up, I would change my computer over to static and enter in like 192.168.101 dot, let's say 2. And then I would be able to, and obviously the subnet mask, I would then be able to find the Kumo on my network. Once you're into the web UI, right? Once you're able to actually log into it, you would type in your browser 192.168.101.1, and that's now the address of the Kumo. And the Kumo is the device that has all the BNC connectors on it. For those that aren't familiar, the control panel is the one with all the buttons that controls the Kumo. Let's just look at these couple of fields here. In the IP address type, switch it to static, and this is where you're going to give it a static IP address. At this point, I would have my spreadsheet open either on my phone or my computer. And now I can enter in the MAC address, which is listed right there in gray. I can list the IP address and I can label it's the Kumo. So now I know that this device is always going to be at .50 whenever I need to find it. Another little hidden thing next to system name, if you click there, it's not super obvious, but you can actually rename the panel. Super helpful because the control panel on a AJA side of things can control up to 4 different video routers. And so I'll show you in a second, but when you use this, on the bottom left there, it says router 1, 2, 3, 4. With one control panel, you can control 4 different Kumos, which is amazing. You could have 4 32 by 32 routers and you would just select them and then you have full routing capabilities. Let's show you what that looks like. You can connect the control panel, which is what we're looking at now. It's the 1U shaped device. You can connect it directly to the Kumo and just have direct access. The thing that you're giving up is you're going to not be able to access it on your local network. And AJ did a really good job of building a web UI that gives you a bunch of advanced features, and we'll show you this in a second. But you're going to do this pretty much the same exact setup, but make sure that you give it a different IP address. So the Kumo with all the BNC connectors is .50. The control panel, the CP, is .51. And then you can see the MAC address there. enter all this information in your spreadsheet. Why not? Keep that going. And then in the home page of the CP or the home tab, now on router 1, you can select DIT cart. And the thing that we have highlighted there that says DIT cart, that's the Kumo that we just set up. If I had 4 different routers on my network, I would want to label them so I wasn't mixing up which router goes where. So again, organization done in prep saves so much time trying to troubleshoot. And at this point too, use LAN scan, see, just confirm that both of these devices show up and they're on the same network. It's a great kind of like trust but verify moment, just to make sure everything's working right and they're using the IP addresses that you gave them. The reason why I think that you shouldn't connect directly from the CP to the Kumo is because you'll miss out on this. And their web interface is awesome. You can color code inputs, you can label them, you can lock, you can switch the signal mode from single to double to quad. So if you were doing 6G, you can group 2 inputs as a 6G signal and route them as either one, which is awesome. In quad mode, if you were doing quad HD with 4 1080p, links like quad link, you could then input 1 through 4 would be A camera, and then 5 through 8 would be B camera. Really great to group those kind of settings. It's an advanced feature set. And again, I actually find myself routing on the day-to-day using this rather than using the control panel. There's a good thing to mention that they make a 32 by 32, so 32 inputs, 32 outputs. That's a 3G version. So that's just handling all HD stuff. They make a 12G version, which is a little more expensive, but if you were going to build a new system now, you might want to go with the 12G just so you can handle 4K signals in the future. The price difference is not that big of a difference to justify it, being prepared. Also, if you're using the single rack unit CP, they make 2 different models. One is the CP1, and then the CP2 is 2U, has way more buttons on it. The CP2 gives you control over salvo, which are AJ's name for macros, like if you're in the Black Magic world. So inside of this, you can build out a salvo, and you can build like A camera only, or say, salvo 2 is B camera only, or whatever you want it to be. You can, use these checkboxes to map your inputs and your outputs. The beautiful thing is on the smaller control panel 1, you don't have these physical salvo buttons, but in the web UI you do. So I use this a lot as well. And then once you have the CP and the router setting up, this is also useful for guys and gals with mobile setups. If you have a mobile rig and you don't have room for a control panel with all the buttons, just throw the router in there. And now inside of LiveGrade, you can find your router, and you can do a very basic in LiveGrade Pro. You can make configurations. You can actually route on the fly. It's not elegant, but they did that on purpose because LiveGrade Studio has a full interactive routing capability, which Kyle's going to show you in a little bit. But there's no reason at this point to not have your video router accessed by LiveGrade. You just get more control out of it. And by the way, once you start building presets in here, like configurations, you can assign those to hotkeys, and then your Stream Deck can do A camera only, B camera only, etc. So you just open up the world to more flexibility, more control, and more elegance. But before you want to go there, you always want to start organizing, labeling. Just be diligent about that so that these feature sets don't get lost with you troubleshooting. That's kind of the end of my section. If anyone has any questions about that, I'm happy to answer. If anybody has anything to add too.
I don't see anything regarding that. I missed the last section of that because I was looking at something else. Did you go over the Black Magic as well, or no?
Kyle's going to go over the Black Magic.
Kyle's going to go over top of that.
A couple little things I'll point out about the Azure Kumo router. I mean, the one downside, of course, that was pointed out is the boot time's about a minute. But the pro of it is it's completely silent, and it can run off 12 volt really easy without any adaptation. The heat's actually dissipated through the BNC connectors, which makes it ideal for putting into small mobile cases.
Yeah, good points. Their connector is like a weird little Molex connector, easily found on Amazon though, and it's fairly simple to build a 12-volt connector or adapt it to 12-volt power. I do like also that there's 2 power inputs, so you can have one that's on AC and one that's on your 12-volt, and it will seamlessly switch over as like a battery backup because we know how important the router is to our world. So
yeah, and I would add to that obviously the boot time is not much of an issue if your router has got continuous power all day long. And then also it's to throw in one more reason to consider getting the 12G over the 3G is the 12G is got much more sensitive electronics in it. So if you have a weak signal or a noisy signal, the 12G is going to more reliably be able to lock onto that.
I think it's clear we like AJA routers. We're fans.
I don't see any other questions or anything like that. So
Awesome.
Awesome. Now I get to talk about the ugly stepchild of video routers, the Blackmagic Video Hub. All right, so sorry guys, the Blackmagic Smart Video Hub. So this is the new version. They also, the older version had a similar profile to the Kumo. The main thing with this video router is you're gonna have to set it up correctly. You're gonna have to set it up over USB, just like we did with the color box. And I'm gonna show you guys how to set this up over the Video Hub hardware setup. And here we go. So where we are in this whole process, guys, is we have the Video Hub connected over USB currently. And also the Ethernet port in this specific instance is connected to the edge router, but it can't communicate currently. So when you connect over USB, you go into the Blackmagic Video Hub and it'll allow you to go into the configure page, and you're gonna set that static IP address just like we've been doing on all our other devices up till this point. I give the 10.10.1.5, and then we got to point that gateway to our router, and then we press save. Immediately, once this has been configured correctly, you'll be able to open up that Blackmagic Video Hub control, and you should see the population of all your routing. You can also check this over LAN scan like we've done on previous setups. But after this has been roughly set up, I'm just going to take us into the LiveGrade configuration and how to do this. So the very first setup we're going to want to do is we're going to want to go to the video routing. That's under the LiveGrade's first tab there, and go to manage configurations. When we're in manage configurations, we're going to want to set a new config up. And what's important here is making sure that you have the IP address that we had just put in there. So we're going to change it to the 10.10.1.5, and then we're going to go fetch in and out information. So that tells us that it's communicating to LiveGrade, and then the next step after that point is we're going to load all the connections that are currently set up. So a quick little tip that I've come to realize is it's sometimes easier when building these configurations to do them in the Video Hub controller before you load, instead of doing it all in LiveGrade. And then once you set a config, so we'll call this first one our base config, and then we'd want a config that would only show A camera, then one that would only show B camera, and so forth. So you'd want to set your config in Video Hub, come into LiveGrade, load them in, and then save. Because you'll see here, I've loaded in all these settings, and now I'm just going to save it. I'm going to call this my base config. So I would want to repeat that step for all A camera, all B camera, all C camera, and etc. And they'll all be listed right here. And these config files are what you'd be pulling up by using a Stream Deck or any of those other quick recall programs. And the next thing that LiveGrade has done here with this latest version, if you've upgraded to Studio, is it actually has a graphic user interface for router control. So this is great for when you're in a mobile setup and you're just need a quick top-down view of your routing. This allows you to quickly view where everything's going. You'll want to put in that IP address that we have set up for the video hub. And is it playing? There we go. So we're going to enter that IP address and press play. So now you get this, well, it looks like a limited view, but if we pull it over and you'll release it, you'll realize more and more of your outputs show. So full screen, you can kind of see how the layouts work. By clicking on one, it'll isolate it and you can see exactly where it's going, because otherwise it's a little bit of a rat's nest. So you just click your output and then you click where you want your source to come from. It's pretty cool. You can change your color setups and get it as customized as you'd like with that. But I think it's a cool feature and I've used it a bunch and it's come in quite helpful.
This thing is super useful for mobile rigs too, where you don't need a control panel. You can control a router just with this interface. It's awesome.
Definitely can't recommend it enough. So the next step here, guys, is if you have one of the newer video hubs, you can actually set it up from the front using the jog shuttle and the take and menu buttons. It's a tad cumbersome having to scroll through all the numbers to get it set up right, but that is an option. I prefer to use the software utility just because it's so much cleaner and quicker to put everything in there. And then, yeah, there's some further examples of how you'd set it up using the jog shuttle. And yeah, any questions, guys?
Doesn't look like anybody has any questions as of now.
Awesome. So I believe, Nate, you're up next.
Sweet. Okay, so kind of we're just going to overview where we've been and where we should be. After you've set up all your devices, if you are doing it this way, you can set your computer back to a static IP address. And you know, here we've got our 10.10.1 again. I just, for my own whatever, I just use .24 for my computer, just because I like it. No other good reason. But so static IP, and then you should have something kind of set up that looks something like this. So, you know, you've got your internet plugged into WAN, you know, Ethernet 0 if you have that, but then you just have the one cable going from the edge router to your switch, and then all of your other devices should be plugged into your switch. And this was asked, but to reiterate this is mostly because when you're communicating over your network, if you don't have to go through the router and use router processing power, then that helps your network. Granted, everything we're talking about here is not particularly data intensive, but this could apply much later down the road when we're talking about pushing traffic, significant traffic, out through the router to the internet or to some other LAN. So this is what you should look like. Now, if you didn't want to use a switch and you only had 4 devices and you're going to stay that way for a while, you could have something that looks kind of like this, where you've got your computer, your one LUT box, and your one video switcher. Likely this isn't going to be your situation. You're going to probably be this situation. But yeah, and I want to stress something, and when you're talking about purchasing a switch, you know, yes, you could get just your 4-port switch, just to give you just the 4 ports that you need. But if you need more than 4, definitely don't say, hey, we'll use a 4-port on the edge router and then get another 4-port switch just to give you your 8 ports. Just go with an 8-port switch. Then, you know, you've got some room to breathe, and it's all on the switch instead of router and switch. Just another, you know, brief overview of LANscan as a tool. A couple of key boxes here that the one that I think didn't get highlighted is in the bottom left here. And this could trip you up sometimes. You know, all of us who have been talking about it are pretty familiar with it. But down here in the bottom left, you want to choose your appropriate NIC. And that's critical because if you're on Wi-Fi and you're physically connected to your network, you could be scanning your Wi-Fi network and not your physical network. They are 2 different things to scan. So just make sure that you click that little drop-down box, and there should be at minimum 1 to 2 options, if you only have one network connection going. But if you have a built-in Ethernet port, it'll be listed there. So like for me, Ethernet 3 is my Thunderbolt adapter. And that only shows up in here when it's connected. So just something to note, take a look at that. There's a slight typo on this. This is an alternate switch. This is not a router. This is another switch from Ubiquiti. This is a PoE powerable switch. You can also use an AC adapter. And I believe it's 24 volts input on this. I can confirm that, but what does it say there? No, it's 48 volts, excuse me. It's 48 volts PoE. So you can power this with a PoE injector for DC powered carts. That's a conversation. But this is also a managed switch. So this is when you get into more advanced stuff with your network, that'll come in more in 102. So like if you wanted to segregate, maybe clients who are on your Wi-Fi when we get to that from your camera control network, you can put your access points that are just for client on one VLAN and then your camera stuff on a different VLAN. VLAN stands for virtual local area network, which again will come up more in 102. So then you should have a topology that looks pretty much like this, or if you're just doing the router, like this. But probably going to be this, and this is what you've been seeing the whole time. I don't know that anybody's going to have any quick questions right here, but if you do, please, by all means.
Yeah, someone asked real quick, is the edge router 10 times too big? 10x, I guess.
Yeah, I was going to answer that if you don't mind.
Yeah, go for it.
So just so you guys know, like we're showing you guys, edge router, Ubiquiti line, like there's so many options out there for Ethernet and networking devices. Feel free to go your own route. We're just trying to pick the simplest things that give us enough flexibility for DIT work. The universe out there is endless with different devices. But like for the reason why we chose the smaller edge router, instead of like the edge router 10X, which gives you 10 ports, is like we can use our NIC gear switch to handle all of the switching, right, for our devices, and it offloads that process or the processing power off of the edge router. I think if you went with the edge router 10X, it probably has a better CPU and memory in there so that it can handle
much better.
Yeah, like much more strenuous. Like if you were doing 1080p streams, over each port, you'd want a better router to handle that kind of thing. So it depends on how you're going to use it. But for our carts, a switch is kind of a great way to just like offload the processing power from the edge router. So the edge router is just being used for DHCP and for PoE for like an on-cart access point that only needs one cable to power it and provide data.
And if I can add on to that, just, no, there's no switch that's too big, in my opinion. I mean, at a certain point, depending on how in depth you want to get, you're always going to find yourself wanting more ports. And, an edge router that size is nice. At the same time, I prefer to have just the amount of processing power that you need in a router, and then otherwise put everything on the switch, because that really just offloads a lot of the hardware processing to a different piece of hardware that can then, like Jamie has already said, so then you can reserve the router processing power for more complicated tasks. When you get down the line, if you guys are going to be working on shows where security is significant, but you do need to be connected to the internet, operating complex firewall rules is something that you can get into. Definitely beyond the scope of this class, but the edge router operating system has incredible tools for firewalls and just how much configuration you can do there, or running a VPN client through the edge router. That takes up a significant amount of processing power.
Yeah.
So that's when a bigger edge router would be helpful in terms of processing power.
As Nate was saying too, think of your switch as a power strip. A lot of us keep many power strips in our cases on the truck as backup. You're going to do the same thing with switches. Have small ones, have big ones, have ones that are 48 ports, depending on the job, or rent one if you have a job coming up where that seems to be necessary. But again, think of switches just like power strips, and then you'll see that having a few on hand is always great, just to expand your network, if only temporary for the day.
On any given day, I have at least 2 switches floating around in my truck, just
Yeah.
because. Even in my daily life, they come in handy. I'm helping family or whatever. Let me plug in a switch.
Yeah, and another reason to avoid oversizing your router is power consumption. The amount of power current draw at idle is going to be higher on the 10X than it is on the ERX. So if you're running it off battery, you're going to get more runtime.
John Waterman has a question. Jamie, yeah, it seems for you.
Yeah, the question keeps coming up about swapping back and forth a cart rig and a mobile rig. Do you set each rig's equipment with identical IPs if you were swapping a laptop back and forth? I personally don't duplicate the IPs because you're just asking for trouble if for any reason you ever want to connect both. And like, again, if you follow the example of how we set up, basically you have .2 to .99, you have 99 devices. So just maybe make your mobile cart .2 to .20, and then your main cart is .21 to .50 or whatever you want. Like, so you can segregate it that way. But as long as you have a spreadsheet on the laptop that's going back and forth and you keep things organized, you can accomplish it with static reservations or static IP addresses, or even DHCP, to be honest, with just your laptop receiving a DHCP address. There's a couple different ways to go about it. If you're still unclear, feel free to ask some more.
I would just contribute to that, saying that, like, if you are doing those multiple rigs and you're a person who maybe likes to segregate each of your types of devices in like each group of 10. So like your LUT boxes are from 10 to 20. You're not going to have 10 LUT boxes, but if you want that there, and then like your video router stuff is going to be 20, and computers, whatever. If you need more space, you can adjust your DHCP server. If you need more than that .100 to accommodate how your organizational method, say, hey, make your DHCP start at .200 to 254 and only provide 54 automatic addresses, and use the rest of it for however you want to organize your other stuff. That's flexible. You can move that around.
John asked a follow-up question. So in that case of equipment with their own IPs, then you must re-add all LUT boxes each time you swap. So it's funny, this came up and I had talked to Pomfret about this, about having multiple carts, because on certain shows I have 3 different setups. So they enabled a feature to save like a config file for your LUT box setups. So if you have 2 box IOs and dual channel modes, you can do 4 cameras, you can save that as a preset in LiveGrade. And then when you switch to your mobile rig, you would just load the mobile rig config, which would, be whatever it is. And you should be able to bounce back and forth between that. The problem is it's still not great. They're working on it. You still need to kind of re-add some things, but my hope is that they make it more elegant so that, you plug your laptop via Ethernet on your mobile rig, you change over your preset in LiveGrade to mobile rig, and then boom, it connects to all the LUT boxes that are on that network, and vice versa. Any other questions before we move on, guys?
Nope, doesn't look like there's anything.
Good questions though, and everyone don't feel intimidated. Feel free to ask any questions you want. We want everyone to answer or have any kind of curiosities answered in this session related to 101.
Okay, let's move on to troubleshooting.
Quick question from Zach.
Yeah.
He asked, do you need to pass off the edge router?
Can you clarify what you mean there?
I think he means take the edge router. If you have 2 different setups, do you take the edge router with you between setups? And I would say no. The edge router is small enough and cheap enough. Just have 2 or 3, depending on your setup. Again, once you build this out, the beauty is, like, if you're using a laptop to LiveGrade, just move your laptop over, plug in an Ethernet to your mobile rig, and you're pretty much done.
Yeah, I would just say have multiple edge routers. And then Gabe says, would it be possible to have a mini rig set up via USB and no edge router? You mean like with just a switch?
With colors. You'd probably
with colors.
Yeah, the box IO you can't control over Ethernet. So to Gabe's point, you can only do colors. Kyle, do you want to talk about that?
Yeah, I tend to avoid using the color boxes over USB. If it's a situation that you don't have your rig built out with an edge router, then yeah, you can get by in a tight spot. But I would just say get an edge router for your mobile rig setup and just duplicate the config file once you've already built it for the main system. And now you have two identical edge routers. All your devices carry their IP address, and those are going to be static. So it's really just going to be plugging and playing from that end of things. I hope that helps answer that.
I will say, just because I've done what Gabe was asking, if you're in a situation where you can't do an edge, you have to do USB, you can do it that way. The only thing you have to do is set up the USB, the IP over Ethernet for USB is the same for all colors. So make sure you just change one of them, because otherwise you won't be able to see both.
Oh, to Charlie's point, if the default IP address of the color is 192.168.101.1, I think we stressed this earlier. If you have 4 box IOs and they're brand new, don't connect all 4 box IOs to your system and then try to figure out which one's which. Take one, label it with P-Touch or tape, plug it in, set the IP address, disconnect it, move on to the next one. If you connect multiple devices upon initial setup, you're just going to create a world of hurt for yourself. Just do it one at a time. But if you're trying to connect colors, again, it's the same thing. They all have the same default IP address. So what you can do is change one of them to be 192.168.100.1 for a camera, and then the other one would be 192.168.101.1, which would be the default. So you can have multiple colors over a USB network. It's just USB doesn't carry as much bandwidth as Ethernet, and it's just kind of more problematic, but it's certainly doable.
To be clear, the USB employed in the colors doesn't carry.
On the color, it's emulating USB.
It's USB 2.0.
Yeah.
So it's not that fast.
But in a super tiny rig, go ahead, do it, but test the shit out of it before you employ it.
And as an analogy to what Jamie was saying with the whole multiple of the same devices, you get like a Spartacus situation where it's like you send a command to something, or you're trying to talk to somebody, and you have 4 new box IOs. They all have the same IP address. They're all going to be claiming that they're the one that needs to, get that information, and so then nothing happens. Is one of the things that will happen. So, and I guess that kind of brings us into troubleshooting. If you guys are ready for that.
Perfect segue.
Yeah. So in terms of troubleshooting issues, you always start at the physical. The physical. Do you have an air gap? Are your Ethernet cables plugged in? Great. If they're plugged in, do you have a link light? I think I talked about this earlier, or maybe I didn't, but any switch or router or any networking device typically has a link light on it. It's either near the Ethernet port, or on the case of the edge router, it's on the top. So I don't know if you can see this, but on the edge router, they're right on the top. But a lot of networking devices have them right next to the actual ports. So that's an indication that you have an electrical link between your devices, that you have a loop. If you don't, but all of your devices are actually physically plugged in and powered, then you might have a bad cable. So a good way to, test that is say, hey, I have a cable that I know is working over here, plug it in that link. And if you still don't have a link light, then you might have a problem with one of your devices or a port on that device. You could also try switching a different port on your switch, because it is possible for just a single port on a switch to get burned out. Doesn't happen very often, especially these days. It used to happen a lot, in the 90s, but it doesn't really happen much anymore. Then the next thing to check going up from there is your IP addressing. Do you potentially have IP address conflicts? Are you statically assigned? Did you assign a static IP address that maybe something else in your network is already has? So, you got to play with that. Use LAN scan. If you've set something with an IP address that something already has, you can use LAN scan to check. Just make sure, reference your document. But LAN scan is kind of your backup. And then up from there, if you're still having issues like, hey, you can see your box IO in the IP remote utility, but it's not showing up in live grade. Well, then you might have some issue in live grade. Reboot live grade, reload it into your slots. Try there on the software level. Adam, we'll get to your question in a second. Well, hold on. Adam has a question. We've got an 8-port unmanaged switch and static IPs for all my gear. No router being used currently, and a manual IP address gateway on my host machine? What functionality am I losing by doing it this way versus adding a router? So he's not running any DHCP server. Is this bad? I would say as long as you're managing your network and all of your static IP addresses, and you do not anticipate any need for automatically assigned devices, then no, this isn't bad. It's just you have to manage, you're managing your network. And so you can't just pop something onto your network and then get an IP address. You have to know where it is. So if somebody else is coming into your cart, and for instance, maybe they don't have your document, but they need to be able to plug in. If you have it as a switch and no router, there's no way that they can necessarily know what IP address scheme that you've used. So sorry, Jamie, if you wanted to add any more to that.
Just it's a little bit outside the scope of this, Adam,
Yeah.
but once you start adding wireless clients like camera control to your network, which is not in this class, and also iPad streaming, etc., like with Teradek serves. If you don't have a router, every device, like every producer, every makeup artist that wants to get their iPad on your network to see a video stream, you now have to assign them a static IP address, right? And so you can do that, but it's going to eat up a lot of your concentration and a lot of your time, and you also have to keep track of that stuff. And the thing, it's a really good example that, like, let's say, somebody wants to just they're on your show for a week, but your show goes on for 6 months. Like, so you give them an address, but now you manually have to like release that address to be available once they're done from working on your show on a week. But if you have a router set up and you have your pools set for static and routing, like we've discussed, your router will just take care of the people that come and go on your network. But for good example and good question, you can do exactly what we set up today without an edge router. You can make a whole cart set up with an 8-port switch, sign everything static, and you're off to the races. It's just handling the variables. Like even an iPhone, if it wants to join your network, you would have to give it an address, because the iPhone's just going to sit there with no way to access your without an, it's nothing is going to give it an address unless you do. So that's kind of important to mention, that it doesn't hurt to have a router, but the router can also lead to more unpredictability if you're not confident with setting it up.
And another thing you can kind of think about as well is if you have a really basic setup where you just have a couple LUT boxes and a video router attached, it's like that can just be a closed static IP networks hooked up to a unmanaged switch, and then have an open port. And as soon as you need to start adding functionality like video streaming or anything like that, then have a router ready to go. You plug that in and away you go.
Okay. Looks like, oh, Gabe. Oh, no, never mind. Sorry. Moving on.
Hey, just one more quick thing, Nate. I love this troubleshooting diagram, just to compare it to like video type things, like when I'm training people to be utilities, etc. I always say start with signal and power, right? So like if you're not getting picture on a monitor, examine those two things, and then it starts to get more complicated if you're dealing with wireless. Funny, if you're using Teradek to stream video or to transmit video, the wireless adds a whole nother aspect of troubleshooting to it. Same with networking. But if you start with the basics, is it powered up? Is the cable good? You can start to like reduce the amount of variables and work in a methodical way to help troubleshoot. And that's what we're trying to show people, is like when you're in the weeds and you're super stressed and the DP wants to see something, build your network cleanly and efficiently from the beginning, so that you don't have to spend time troubleshooting, because time spent troubleshooting is time not spent impressing a DP.
And to add to that, to reducing the problems in terms of troubleshooting, one of the reasons why the document, keeping track of your stuff is so helpful is that you can remove, sometimes, occasionally, a router can start doing weird shit. Right? It can just do stuff that's weird. So being able to remove the router, like on a moment's notice from your workflow, is helpful, just in terms of it's doing weird DHCP problems or something. So if you can just remove the router, then you can be, hey, I've already got all my static IP addresses already in there. I just need to configure my laptop, just go on the switch. It is highly unlikely that just a switch will be a problem. So if you remove the router from the equation, that's another good troubleshooting step. And that's where that document comes in so handy, is that you can already know what everything is. You don't have to rely on DHCP and the router if you don't need to, at least in terms of troubleshooting.
We have 2 questions.
Yeah, so to answer Scott's question, he basically asks, are there any issues at a camera house if multiple DITs use 10.10.1.1 as their computer IP address? I mean, typically speaking, we suggest that 1.1 is set as your router. But let's say you have some weird example where you have 2 computers networked together and they're using the same IP address. You're going to get a IP collision warning.
To be clear, it sounds like, Scott, you're talking about if you're prepping at a camera house and Jamie's prepping at the camera house, and you guys both have your own local networks and you're testing your stuff, but then you guys are both connected to the camera house. In that, if that's the example that you're talking about, the answer to your question would be no. There wouldn't be issues, because your local network is from your router down to your rack, and then you're just talking to the camera house via your laptop. The camera house doesn't see your network. They can't see your network at all. So if somebody else is connected to the camera house but not connected to your local network, they are invisible to each other. They don't exist. If that answered that question. Adam asks, is there anything that we've talked about today that would be going on the router and not the switch? Do you have an example? Potentially, in this case, a single access point that you could use the PoE output from the edge router. That's the only thing I would do personally. And even then, if I were going to be doing multiple access points off of my cart, then I would do that off of a PoE powered switch, like the Ubiquiti one that we saw earlier, or, well, that one only has a single out as well. So I would use a PoE switch probably. But otherwise, no, Adam. My standard practice is the router has the internet input and then one output to a switch, and that's it. Yes, agreed. That definitely sets up for more for 102. Absolutely. Timur says, sorry if I missed it, but can you explain the managed and unmanaged switches for our purposes? Yeah, we touched on this, and this is definitely going to be more advanced in 102. And there aren't a ton of applications for us, but what a managed switch is it allows you to specifically segregate physical ports and designate them to a segregated section of your network, that you could have a separate DHCP server running there, or separate IP address scheme, but they are electrically separate from each other. So that's what those are for. And so you would use that if you did have a wireless network that was connected to your switch, and you had like one access point dedicated to clients, for example, who were doing iPad streaming or something, and you did not want them to have any chance of conflicting with your camera control. You could do a VLAN, and which electrically separates those two networks from each other. And so then there's no chance of them interfering with traffic on your camera control network. So yeah, yes, you could. Yes, Adam says lets you manage bandwidth too, I believe, right? Like the size of data packets. Yes, you can do that, and that's definitely way more nuanced, way more advanced in terms of traffic control, quality of service types of controls for your network. I would say that's even beyond kind of our 102 class. That's definitely kind of advanced network traffic control.
Yeah, for people just kind of getting started and that want to like revamp their networks that they already have, just get an unmanaged switch and just start with that. And if you're looking for more control and more like access stuff, then start researching managed switches. Like the Ubiquiti one that we posted, just has a lot more controls over individual things. A lot of it you really don't need on set yet. We also have the slide up, the spreadsheet. Yeah. This spreadsheet we shared as a blank document with the headers still in there. In the white paper, not the white paper, the zip file that we shared. highly encourage everyone, just, it's pretty straightforward. Just fill this out as you go. Keep it in a cloud on Dropbox or iCloud or something like that. So you can always access it on your phone or your laptop, or share it with the utility they can help you fill stuff out. But filling this out as you go is just super critical, man. It just saves you so much headache.
Also, a quick note on that: it's a good idea not to have this document widely available to just anyone. You do want to keep it private.
Yeah.
Why is that, Chris?
Because the MAC addresses, if you have some nifty board op who likes to do hacking in the evenings, you can hack into your system really easily if he knows your MAC address.
It's probably not a huge concern on our sets, but it is, just being a security conscious person myself, a MAC address is like, you could think of it as the equivalent of your IP address is your email address and your MAC address is your real name.
That's,
you know. So it's a little bit, it's kind of just basic security consciousness.
I ain't scared.
And if it isn't a spreadsheet, another thing that I like to do is just to have a bookmarks folder active in your favorite web browser, and just bookmark all of the IP addresses, and you can name them so you can click there. Alternatively, you can create your own host file, so you can just type in the word, MacBook Pro or Box.io, and you can get there. But the point is, just keep a good record of this, and you can do whatever you want with that information.
Good point, Ryan. I forgot to mention that in Chrome, I have a bookmark folder with all the devices that have web interfaces on my cart. And I can just click on that folder, hierarchy and launch all of them if I want to, or just get into that and say, oh, I just need to get to the Edge router, or I need to get to the AJ web interface. Super useful. Just one more step of just organization.
And if you're feeling fancy, you can put them in iframes to have a multi-view on a single page.
Jeez.
So Ryan just kind of glossed over something while he was explaining that. He was talking about a host file. Just so you guys know what that is, it's a host file on your computer. Windows has it, Mac has it. It's a file inside the OS that essentially tells the operating system, hey, it's a manual translation. When I say boxio.com, that means go to this IP address. So it's a manual mapping. Say that again, Ryan?
Like an internal phone book.
Yeah, exactly. So that is something that you could do to make things easier if you wanted to, but that's, like he said, that's getting fancy.
Yeah, moving on.
Moving on, yeah, going back to troubleshooting. Cool. So this is kind of all the stuff that we were talking about, just using that workflow diagram, but like, are they plugged in? Do you have the lights? I talked about this, switches are less likely to be problematic, so that's why we use that. If you're static, are you in the right static IP address range? Were you connected to some other network that was 192 and you need to be on 10.10.1? Again, this is all just kind of everything that we've just went over already, but it's here for reference. Definitely, here's one thing to know. I don't know if I said this earlier on, but if you have a static IP address for a different network and you hop for a 192.168 network, for example, and you hop onto your 10.10.1, in system preferences, your connector, on that interface, it'll show green because it's a valid IP address, but it will not, you won't be able to talk to your info, to your devices. So that could be a misleading thing. So just something to be aware of. Make sure that if you are statically assigned, that you are in the correct subnet. And lastly, number 7, we were supposed to remove that, but number 6 here is, if you can use ping, which Jamie is going to do a little bit more of here in a minute, but if you can use ping and you can talk to your device, like a Box.io, for example, if you can ping it, but like the IP remote utility won't talk to it, then that could indicate that while it's there, it's powered up and it's responding at the most basic level possible for a network device, there's still something else going on with it that won't let it communicate on any higher level. So first step there is, maybe power cycle the device that you can't communicate with. It's also possible that your device could, that you're communicating from might need a power cycle just to kind of reset maybe some of the routing tables, some of the low level stuff that we don't
Remove
need
the
to go
ghosts.
into. Yeah, the ghosts in the machine. But yeah, so that could just be an indicator that, hey, it's there, but might need to be rebooted. And ZenMap, it's just a tool for looking at ports, but Jamie's actually going to talk about that a little bit more with an easier tool than that here in a second.
Cool. Any questions before we move on? No, I guess not.
Don't see
All
any
right.
questions, so go ahead.
Sweet. Yeah, we're going to just focus first in terms of troubleshooting with terminal. And I know I'm always telling everyone to use terminal. I really think the sooner you get started, just playing around with it, trying to understand how it works, just try and use it. It's like anything, you'll figure it out. When I'm working on networking stuff, we demoed it earlier. Ping is like the easiest thing out there. If you're in terminal and you type ping and the address of our router, 10.10.1.1, it's going to send up your computer is going to send a packet out and try to bounce it off of the device. And every device by default, it's a little complicated, will respond back saying, hey, yeah, I exist at this address. Cool. It's really obvious when ping is not receiving an address, but the screenshot that we have right here shows ping working. It's saying, I'm receiving a packet. I've sent 4 packets, well, 5 because 0 counts. And this is how fast or how long it takes to send a packet and to get it back. So when you're actually trying to troubleshoot stuff outside of your network, say to like a web server you've sent up, the higher the millisecond count, the longer it takes for data to go back and forth. Just something to remember. Inside your own network, it should be low numbers like this, below 1 millisecond. A useful thing when I'm troubleshooting, especially if I'm deep in a rack and I can't see my computer, but I'm trying to figure out what's not working, I'll use ping-A and then the address of the device I'm trying to reach. And once ping starts seeing a response back, it will, in the dock, it will start jumping up and down, which is really adorable. And then it will also make an audible bell on your computer. So turn on the volume. And if you're underneath your card or something like that, you were like, oh, cool. That device is now reachable. I've used that countless times. Traceroute, a little outside the scope of this, but we thought we should just mention it. It tries to map out the hops that your network has. So if you're trying to find a route to Google and you run traceroute 8.8.8.8, which is the address of Google servers, it will show you every single path or hop, like a router destination that your data takes. And sometimes it'll be 20 hops long. Sometimes it'll be 4. It totally depends on how close you are to a server. Traceroute's going to be really useful once we start getting into like mesh networking, where you have multiple access points on a network. And if there's an issue, you can run traceroute to see which path your data is taking and if it's missing a mesh point, or if it's having an issue not going past a mesh point, it's a really great way to troubleshoot that. Again, a little outside the purview of this class, just because there's only one hop, there's only one hop in our current network. ifconfig, kind of a default go-to tool. It will show you all your networking or NICs attached to your system. EN0 is your Ethernet, right? And it will show you the MAC address of your actual NIC. It'll show you your IP4 and IP6 addresses. Super useful for just troubleshooting. If you wanted to see your Wi-Fi, that would be, correct me if I'm wrong, no, EN0 would be Wi-Fi, and then ETH, like 1 through 15 or whatever, would be your NIC. We're not going to go super into detail on this, but I want to follow this up
it might
with.
be helpful to note on that if you go back one.
Yep.
So on ifconfig, it'll show you everything on every interface, virtual or physical.
Right.
So you kind of see some of these down there, P2, P0. That's not a physical interface. That's actually a logical interface. And if you look, you can see the MAC address, which is right below the red box of EN1 or EN0. And you look at the next device, it's the same MAC address. So that's a virtual interface. So you'll see a lot of information there, but you're just looking for the EN01, those are going to be all of your physical interfaces. Everything else is going to be a virtual interface.
Right. Good point. But we're just glossing over this kind of stuff because we're trying to encourage people to get more familiar with the terminal. Don't be scared.
This is your gateway drug.
It's just a gateway drug. Man, it's kind of funny. It's short for manual. So if you're trying to figure out how to use ping or traceroute or ifconfig or any other program that's built in or that you've added, type man space ping, and it's going to show you the entire manual for ping. And you can see under synopsis, it shows you like you're going to type ping, and then this is where you do your options, which it looks scary, but -A stands for something. And if you look below, -A stands for audible, outputs a bell. Super simple, you know, and it shows you the formatting and the syntax that ping expects for you to do. If you do ping -C, it stands for count. You can send 100 packets. You can send unlimited packets. If you're really trying to troubleshoot something, you can have ping just keep sending packets at different speeds over different interfaces. It can wait. It can do a whole bunch of different things. But if you type man ping, man traceroute, man ifconfig, it will give you the whole manual for all of these things. I keep a little notepad and pen and paper or pen and pencil near my computer because it does get a little, you can string a whole bunch of options together and it can get a little hard to remember all that stuff, but don't be ashamed. Even the most experienced people take down of all the options. If you are scared, open up network utility. It's the same tools, but with a graphical interface on the Mac side of things.
Where is network utility, Jamie?
It's in applications utility, network utility, or just use Searchlight or Spotlight like I do. But yeah, so now under network utility, it's the same tools that we just showed you. So if you do that drop down, we're looking at a USB-C to Ethernet NIC, and then we'll show you the same MAC address, the link speed, really great for troubleshooting. If your data is going really slow, could be the wrong link speed. Really great to just verify that it's not running super slow or it's running how it should be.
Which, Jamie, sorry to interject. If you see a really low link speed, that could mean that you have a bad cable.
Right.
That you're still getting a link, but it's really, really slow. That can mean that the end is really not great, bad termination. Or if you're going a really, really long distance, you'll see something like that.
Yep, exactly. Let me just go back here. Oh yeah, so we have, just a general overview. Theoretically, if you had two devices on the same network or clients with the same IP address, you would see a collision count go up, something to keep an eye on. If you see anything besides 0 in collisions, you've got issues. You've got two devices with the same IP address. And also, if you're trying to reach a device and it's really spotty and problematic, that's another indication that there might be another device on your network with the same IP address. That's why we're stressing be methodical from the beginning, so you're not having to troubleshoot that kind of stuff later on. Some of that stuff can be really hard to diagnose. So just for a good example, the GUI for ping, super simple to use, really obvious when it's working, really obvious when it's not. Send an unlimited number of pings. If you select that, again, if you're trying to troubleshoot something, just keep having ping every second. It's going to send out a packet until it starts getting a response. And enable the bell so that you can hear the response. Port scan, we thought it would be interesting just to show it. This address that we have here, 10.10.1.1, is our router. We're accessing the web interface over port 80. You don't have to type that in because port 80 is assumed that that's where the web browser is. But you can also SSH into it, which is a way to using the terminal to log into the web the router and make changes through that. And then there's a HTTPS secure. There's tons of common ports out there. 8080, secure HTTP. 80 is typically like if you're running a web server on your computer, its default is usually going to be port 80. So what that would mean is 10.10.1.1 /80. FTP is port 21, SSH 22, etc. It can be really useful for this stuff when you start working on streaming, because you're going to have to forward data over ports. to get that data out behind a firewall or out behind your router to the internet. So we thought we would show it. We're not going to go into too much more detail, but network utility, just a user interface for doing this stuff in terminal. That brings us to a Q&A if anyone has any questions.
Don't everyone speak up at once.
I think we can move on. I think Nate, you're up.
Did you guys want me to do a demo of terminating a cable?
Yeah, so we have a little presentation here for you guys. Nate, you work on that and I'll just walk through the rest of this if you don't mind, yeah?
I'm ready whenever.
Okay.
So, yeah.
Yeah, we wrote a white paper. It's in the zip file that we guys sent you. We're gonna try and update it regularly. Maybe there's a wiki in the future, we'll see. There's great resources we used, just so you guys know too, where we developed this. We use the CompTIA A+ certification and the Wireless Networking in Developing Worlds ebooks as our basis for understanding a lot of this. And we basically wanted to strip out all the relevant information that DITs need to know. So I'm sure there's some super experienced people in here that are like, oh, you forgot to say this. In this beginner class, it's not relevant. And we think that we covered exactly what you guys should be focusing on first. And as you get the basics figured out, you can grow anywhere. The networking is endless.
Jamie, if I could interject here really quickly. The CompTIA A certification class is hosted on lynda.com. It's a video series. And just in case anybody isn't aware, if you are a good standing member of 600, this is a free membership that you can sign up through on the website. You can do it through the website and just say that you're a good member, and you'll have access to the entirety of Lynda. More specifically here today is the networking classes that they have, and they're really useful. They're broken down into little chapters and everything. It's professionally done, and you can work at your own pace and skip the parts that aren't relevant to on-set use.
We're going to show a quick demo. Nate is going to show us how to make Cat6 Ethernet cable. We really feel like it is part of this class, even though it's a beginner class. Making BNC cables, making power cables, making network cables, super important for every DIT to feel confident in doing. There's no reason to use a 20-foot cable inside your rack if you only need to go 8 inches. It's a lot easier than you think it will be. We actually provided in the zip file, again, there's a list of all the products we mentioned, and Nate has listed his favorite crimper and his tools and connectors. You'll see how easy it is. Go ahead, Nate. Let's see what it looks like.
Okay, so I have both. I have 2 tools here. This is the newer one from Platinum Tools. Their EXO design. They actually have like different dies that you can pop in here. So you can crimp phone cables, you can crimp probably, I don't know, all sorts of stuff, but I only care about Ethernet. So, and I actually don't like this tool quite as much because it doesn't have the stripping and cutting tools that the older tool does. So this is for the older EZ45 connectors, which I have here. There's not a ton of difference between them, between this one and the newer ones. The biggest difference is that the newer ones stagger where the wires come out here, as you saw in the picture earlier. But here, I'll just go ahead and do it. I'm gonna use this tool here. Strip it back. So you can see here, this is Cat6. And this is technically what's called Cat6e. Cat6e was manufacturers making cable that they were anticipating the Cat6a standard, but it wasn't out yet. So It just has a separator in the middle for the 4 pairs. This is just for cutting back the jacket, this little string right here. So we're just going to cut that off. This guy here. And then we go ahead and start untwisting our pairs. Now, both of these tools have on them, let's see if that decides to autofocus or not. Probably not. Yeah, I didn't think so. But right here, it has the listing of the order that you want to go in. And this standard is called TIA 568. So if you just Google TIA 568, which this is, I don't know if this is anywhere in our document, we should probably add it. But that is the pin out essentially of these cables. For the most part, TIA 568B is the accepted standard at this point. So that's the one that we'll use during the tedious process of untwisting these wires. So the order, just so that you guys know, I'll tell you, it's white, orange, orange, white, green, green, white, green, blue, and then white, blue, green. And the main pins that get used are the center 4 pins for data. Now, if you're talking about power over Ethernet, then there are varying configurations of how that works. But for the most part, it's these center 4 pins that are the ones that are used. I tend to kind of just run my fingernail along these a little bit just to straighten them out, because then it's easier to get them all to align better as a group. Brown, white, brown is the last section. And you just do a nice wiggle. So you can get them all nice and straight, except for the ends, which are still a little wiggly here. So they're still kind of crooked. So you can either take the blue tool, which is what I would typically use in the field, or since I have these here, I'm just gonna chop off the ends. Now they're super nice and super straight. Then we take our connector. This is the regular EZ45 connector, and take it with the contacts facing up and the clip facing down away from you. Slide these in. And now with an EZ connector, you see these come out the other end. And also with the
Is this
EZ
what makes
connector,
the connector easy?
Yeah, so with regular RJ45 connectors, you actually had to cut the length to the end of the connector. So this was all just molded plastic all the way to the end. So you would have to kind of hold it next to it, measure it, clip it, and push it in enough that the jacket actually got in here. So if you don't have the jacket in here, there's this part right here that gets crimped down onto the jacket. And that's what actually holds the cable in the connector. So if you strip your cable and you get it, you know, you're all the way back here where your jacket isn't in, it's not going to be a very secure cable, and you're just asking for problems.
It's going to be floppy.
It's going to be floppy, and it'll stress on the actual pins in here, and it'll probably pull the pins, out of contact. And yeah, that's not a very good cable. So the other thing that this does, not all EZ45 connectors do this, but probably all the ones you can get now, is that there's plenty of space in here for the jacket so that you can get your cable as close as possible to where the actual pin contacts are. And it's important mostly for high bandwidth applications and long distance runs, because the closer those twists are to the actual point of contact, the more reliable it is. The reason that they're twisted is to eliminate crosstalk and increase bandwidth and distance. Those are kind of all the same function, but yeah. So that's why getting the twist as close to the connector as possible is important. So then just for cleanliness sake, I like to twist these guys off before I actually pop it into my crimp tool, but there's my crimp tool. Pop it in there, grab it here, crimp. I need a new blade on this.
So your crimp is doing two things at once, right? It's cutting the
Yeah.
cable off the end and crimping at the same time, right?
Yeah, exactly. So right here where you can see this screw, there's like a little blade on this. So this is cutting off the ends, and then it's also crimping down the actual pins on this connector right here are actually being pushed into the wires and making contact with them, as well as, like I was talking about, this piece on the back end here that's crimping down onto the jacket. Boom, done. Hey, there it is. So that's your cable. And if you want to get nice and fancy, you can buy yourself one of these. So this is just a basic cable test tool for phone lines, coax, and Ethernet. So this guy has a little guy in the bottom here, so you can easily test like long cable runs that aren't next to each other. Plug one end of your cable here. The other end of your cable goes in the actual top of the unit. Then you turn it on. Boom. And now actually you can see, so my connection wasn't great and I probably didn't pay attention. So I've got 1, 2, 3, 4, and then 6, 5 right here. So I swapped pins 5 and 6. They're not in the right spots. Shit. So you just chop it off and you do it again. You know? So
we have a
We
question.
were meant to do that.
Yes.
So, show that the how to make. We were meant to do that.
Yeah, this was planned, everybody. We wanted to
it,
show you.
it absolutely was.
Yeah, we wanted to show you a band example first. Question: Does the lack of shielding on the connector end up changing the classification / quality of the cable? I.e., using non-shielded connectors on 10 gigabit is going to give you issues.
So I would say just as a default answer, no. But to qualify that, I mean, shielded cables are definitely better if you're running alongside power, which is, as a general rule, don't run alongside power if you can avoid it. But if you've got to be running stuff alongside a lot of power, I mean, if you're just running a little bit of DC power, that's one thing. That's not as terrible. But like if you need to cross, you know, you want to be crossing like this. If you're running parallel, this is when you get a lot of EMI interference. I don't know how many of you know your physics class, but the whole left-hand rule in terms of signal flow and then the electromagnetic field rolling around, it gets induced onto your cable here. So shielded cable will definitely help EMI coming off of other cables running parallel to your Ethernet cable. So the other reason that I like these EZ45 connectors is for the issue that we just encountered, where we had the pins in the wrong spot, is that when you feed that through the end, you can actually, you know, verify that they're in the right spot. Whereas, you know, standard 45 connectors, you can't necessarily. It's a lot harder. You got to actually look through the end of the connector, you know, and it's just trying to look in here and say, oh wait, that's orange, that's green, white, that's green, blue. I don't know which one is it. So.
And just to remind everybody, in the zip file we sent you, there's a product list guide, and we included the RJ45 EZ connectors along with like a recommended crimper / stripper or cutter tool. So
yeah,
should be pretty straightforward.
I'll use, so these ones are now from Platinum Tool for cat that are designed specifically for Cat 6, and this tool, they're called EZEX48. So you can find these pretty much anywhere. I'll use one of these for the next one.
That was a good time to take Dave Satin. You want to ask a question? We're about to wrap things up. We're gonna follow Nate on his journey of making a correct Cat 5 or 6 cable. But Dave Satin, go ahead and ask your question.
It's more of a comment than a question. It's important to remember that this crimper only works with those connectors, right? So
yes.
Once you decide on a brand and style of RJ45s, just like PNCs or anything else, you can't just send the PA over to Dwayne Reed to buy some in case you're running out.
Well, there's a yes and no to that. So like this one, this blue one is definitely more universal. I mean, this one will work on non-easy 45 connectors as well as easy 45 connectors. This will technically even work on the newer ones, sort of, because what happens with these newer ones, this is not a macro lens, so you're not gonna be able to see that, but on the end, there's an extra little bit of plastic that gets cut off as well as the end of the cables. And this one goes deeper on that actually chops all of that off. Whereas this one only goes to a certain depth. The blue one only goes to a certain depth. So there's a little bit of a crossover. You could make it work, but not without knowing it. But this one is definitely more universal. You can still find connectors that exist for this. Platinum Tools is definitely pushing this type of connector as the new standard. And I'm seeing it more and more often. I do work in IT as well, so I see a lot of this. So a lot of the manufacturers are moving much closer towards this type of frame. But yes, these EX connectors are meant for the EX crimp tools by design. So that's where they'll work best.
Correct.
Good point, Dave. Thank you.
Yeah, anybody else have any comments, questions? Does anybody want to see any demos of anything in particular that we maybe didn't cover well enough?
I think we're just anxiously waiting to see if you line the cables up correctly this time.
So I doubt that you can see it, but this one as well, this one is staggered actually, so that you actually get the connectors closer together. Again, that's dealing with the Cat6A specification and determining how close the twists need to be and how close the conductors need to be to each other. So they're very minor differences, but when you're talking about high bandwidth runs and long distance runs, that stuff becomes critical.
Yeah,
So.
John Waterman had a comment about the non-easy Cat 6 connectors.
Mm-hmm.
You really have to untwist the pairs and get them straight, super straight before you slide them in. It's really easy for them to just want to cross over each other. And even with some of the connectors that have dividers to make sure the cables kind of stay in a guide inside of the RJ45 connector, it can still be quite the pain.
Happen. Which is exactly why this part is kind of important. You can kind of fan these back out. Make sure you have your white, orange, orange, white, green, blue, blue, white, green, brown, white, brown. Great. They're actually in the correct order this time because I didn't even pay attention to that last time.
That's your verification step before you crimp.
Yes.
And the beautiful thing is if you did have it wrong, you can just slide the connector off and then
do it again.
Exactly, move the thing before you crimp.
Refeed.
Hey,
anyone's ever done any sort of these connectors before, you do one of the easy ones first. Like, how did I ever do it before? It is it makes life so much easier.
John Waterman wants to know, does the crimper need different dies depending on cable diameter?
No, not different dies based on cable diameter. No. And the only cable diameter differences that you should have are between 6 and 6A, for example. You can probably see this a little bit. There's that little bit of plastic that it's supposed to cut off. I just flicked it off. So now let's test our cable again. See if I got it right. Pass. There we go. Oh, hey, there we go. Boom. Now you had all your pins 1-to-1. Perfect. And now you can do a crossover cable, which I don't think anything we ever use anymore needs a crossover cable. Oh. Rare instances where you have a device that has to talk via a crossover cable, and that's essentially the transmit pins are going to the same point on both end of the connector here. So you need to swap transmit to receive pins, and that's what a crossover cable does. So, but almost everything we have now has an auto-negotiating Ethernet port, so it's probably not an issue. But keep an eye out. Hey, if something asks for a crossover cable, then just do a quick Google on what the pin configuration is for that, and it's pretty easy.
Wasn't there a mention on special thin cable diameter for inside carts? That was like the monoprice cable we showed earlier.
Yeah, and those are all pre-terminated as far as I know.
Yeah.
So those thin cables were just an example. If you're gonna do
a cart installation. You don't want to go down into building your own cable. Monoprice basically makes cables from like 6 inches to 100 feet in different steps of lengths.
Yeah, and that's in the slideshow. So if you download the zip, you'll find that.
Cool. Well, I guess if nobody else has any questions, I think that'll pretty much conclude the Networking 101. Oh, there's one from Ryan Campbell.
Oh, shielding continued.
Go ahead. You can just take it, Nate.
Yeah, shielding continued. I thought that the specifications for differences in cable was the connector quality, twist pattern, internals of cable materials, and shielding. If you don't ground the shield, then that won't affect their own noise each other. And yeah, oh yeah, I get what he's saying. Yes, so that's also important. I said Cat 6A. Yes, it has the divider in between. That's not the only thing that is part of the specification for the cable. It's also the number of twists per meter, such like that. But I feel like the main questions were in identifying the cable. But if you need to choose a cable, yeah, also know that Cat 6A is changing the number of twists per foot. There are more than previous generations. Again, that's to increase distance and throughput over the same amount of distance. And then with shielding, yes, he's very correct. Here, let me go back to this so you can see this real quick. Where did it go? There it is. So on my test kit right here, you can see that this connector has metal around the connector, whereas like the telephone one doesn't. So this can actually test the shielding to make sure that the shielding is good. And what Ryan's saying is like on your device side, if you don't have a shielded port, then you're not going to get grounding. So like these on the edge router, they have shielded ports, but even then you need to physically ground that if you want that to be saved. So there's a specific grounding screw port that you would need to ground to your cart or hopefully to an actual earth ground for that to be really safe. And shielded cables, not only for noise, but also for like lightning. You could actually install a lightning arrestor in line between your access point. This is 102, I guess, but you know, if you're connecting anything that way.
For sure.
And then there was one other thing. What was that? Or no, maybe there wasn't.
No, I think this is it. If anyone has any last questions,
one more from John.
We got one.
Yeah.
Keep them coming, guys. Don't ask.
Yeah.
Now's the time to ask anything you want.
Yeah. So John Waterman asks, so are you all using Cat 6 or Cat 6A for loom run along with BNCs to a TeraDAC access port tree, such as like a what's the thing they have? They're
the monitor mover.
Yeah. Are all cables about the same flexibility?
They're not the same flexibility. Cat 6 is going to be similar to Cat 5e, but because Cat 6 still doesn't require that center divider in it, so Cat 6a is going to be significantly stiffer and significantly thicker. So like when you're talking about these connectors, so like this one right here, you probably can't see, but it's actually bored out just a little bit. There's like a little hump right there, specifically for thicker jackets. This is technically a Cat 5e connector, but with special allowances for Cat 6, just because they have a much thicker jacket. So if you just go buy off the shelf, and they're just going to be straight across, you're going to have a hard time fitting the jacket into a Cat 5e connector with a Cat 6 cable. So no, they're not the same flexibility. And I don't know what people are using in their loomed runs because I'm in a small market and I don't do that stuff.
I think Cat 5e is fine for most applications, but if you want future proofing to a certain degree, just go with Cat 6. It'll be a little stiffer though, if you're doing the 100-foot runs, the cable is just inherently stiffer because of the center core that divides the 8 pairs, or the 4 pairs.
Yeah.
But yeah, it really depends on what you're trying to send down that cable. If you're just putting a wireless access point next to your TeraDAC antennas, Cat 5e is totally fine.
Anybody else with any other questions, comments, anything?
And just
yeah, I can answer that, John. I would say all bulk Ethernet cable that you're going to terminate yourself is going to be solid conductors. Whereas if you're getting pre-terminated cables, you know, from the factory by a robot, could be either. And oftentimes, like some of those more flexible patch cables are going to be stranded. Like this Sonos one, oh, you can't. Oh yeah, you can see that is most definitely stranded connectors. There's no way this is solid core with how flexible it is. So, yeah. No,
Yeah,
not all. But.
Those stranded patch cables, in my experience, you cannot go anywhere near as long of a run as you can with a solid.
Well, no, and that's they're just patch cables. They're just like short runs. They're not meant for anything more than like, you know, I would say I wouldn't go any more than 15 feet with a patch cord, and even that's probably pushing it if you want to get, you know, full speed out of it.
Yep. All right, guys. Well, if nobody has any more questions, I think we're gonna motivate this to an end. We just have a one last slide to thank everybody that put a ton of time and effort into this. We spent a ton of time trying to put this together, so we're really hoping that everyone enjoyed it. And these are the people that helped work on it and develop it. We're developing more classes in the future, so reach out to any one of us if you want to get involved with 102, which is going to be wireless networking. That's a beast of a class. You guys don't need any experience to help. All you have to do is be the perfect dummy that we can ask questions to or bounce things off of. We're all learning ourselves.
See if it makes sense.
See if it makes sense, exactly.
Yeah.
And then just so you guys know, 201, which is built on that, is RF management. So we're developing a bunch of different classes because we realize that there's so much to learn and it never ends. But I'm going to say tip your bartender, but thank everybody, you know, Chris, who did the graphics, Nathan, who did tons of research, Steve with research. I just cracked the whip, Kyle, tons of research and screenshots, Charlie for moderating, Jasper for tons of input. And we had a bunch of other people with input, and Ryan for tons of input as well. So thank you guys. Really appreciate it.
Damon isn't on this list, but Damon's been pretty critical in us getting this ready for showtime. So thank you, Damon, as well.
And if you're going to buy anything, please use the DIT-WIT affiliate links.
That are distributed with the zip.
Mm-hmm.
Yeah. Papa needs a new coat. All right, guys. I'm going to shut this down. Thank you all so much for attending.
Thanks, everybody.
Yeah.
Cheers.